Hi, and welcome to the second edition of our video course on Exam AZ-900 Microsoft Azure Fundamentals. This update to our AZ-900 video covers the latest changes made in 2020. My name is Jim Cheshire, and I'll be your guide as we explore the topics you'll need to know in order to prepare for and take the Azure Fundamentals exam. I'm an author and a trainer. I've written 20 books on various technology topics, and my latest book is ExamRef AZ-900 Microsoft Azure Fundamentals, published by Microsoft Press. I'm a principal EE at Microsoft, where I've been working for 22 years now. I currently work in apps and infrastructure, which includes just about all of Azure, and I'm responsible for our technical support training programs across all of Azure. This video is designed to help you understand all the skills and concepts you need to know to be prepared for the AZ-900 Microsoft Azure Fundamentals exam. It's intended for people who have little to no knowledge of the cloud or of Azure, but if you do have that knowledge, you'll still find this video to be a valuable resource as you prepare for your exam. The video is broken up into 6 modules that align with the objective domain for the AZ-900 exam. In Module 1, we'll start off with a discussion of some of the benefits you get when moving to the cloud, things like high availability, scalability, elasticity, fault tolerance, and more. We'll then talk about the differences between infrastructure as a service, platform as a service, and software as a service. And we'll talk a little bit about serverless computing and what it means in the cloud. We'll also cover the differences between the public, private, and hybrid clouds. Then in Module 2, we'll talk about some Azure architecture and how Azure works under the hood. You'll also learn about some of the core resources available in Azure, like Azure Virtual Machines, Azure Container Instances, Azure Storage, Azure Networking Services, and Azure Database Solutions. In Module 3, we'll look at core solutions in Azure. You'll learn about the Internet of Things in Azure, and you'll learn about big data, artificial intelligence, and machine learning. You'll learn about Azure Functions and Azure Logic Apps, and you'll learn about GitHub and how you can use it with Azure. You'll also learn about using the Azure Portal and some command line tools for managing your Azure resources, as well as how you can manage your Azure resources from your mobile devices. In Module 4, we'll cover general security and network security in Azure. You'll learn about the Azure Security Center, Azure Key Vault, Azure Sentinel, and Azure Dedicated Host. We'll then cover the concept of defense in depth, and we'll talk about the features in Azure networking that can help keep your resources secure. In Module 5, we'll go into identity, governance, privacy, and compliance. We'll start with the core identity services in Azure like Azure Active Directory, conditional access, and role-based access control. You'll learn about the governance features in Azure such as Azure Policy, locks, and tags, and Azure Blueprints. Then we'll talk about privacy and compliance, and you'll learn about Microsoft Privacy Statement and websites like the Trust Center and the online service terms, as well as some of the sovereign regions in Azure designed to meet the needs of governments and certain countries. We'll wrap things up in Module 6 with a discussion about planning and managing costs. We'll also talk about Azure service level agreements and the service lifecycle of Azure offerings. My goal is for you to come away with a solid understanding of the core concepts that will help you as you head into the AZ-900 Microsoft Azure Fundamentals exam. And along the way, I hope you have some fun learning about all of Microsoft's cloud offerings. So let's get started. Welcome to Module 1, Describe Cloud Concepts. This module is broken up into 3 lessons that align with the objective domain for the AZ-900 exam. In Lesson 1, you'll learn about the benefits and considerations for moving to the cloud. Lesson 2 covers the differences between the categories of cloud services, and we'll also talk about the shared responsibility model in the cloud. Lesson 3 goes into the different types of clouds, and you'll learn about the differences between public, private, and hybrid clouds. Deciding to move to the cloud can be a little intimidating, especially if you're new to cloud computing. In Lesson 1, Identify the Benefits and Considerations of Cloud Services, we'll take away some of the confusion about the cloud. You'll learn about high availability and cloud concepts like scalability, elasticity, and agility. You'll learn how fault tolerance and disaster recovery in Azure can help protect your applications from going down when there's a power failure, or worse, if a natural disaster strikes. We'll also talk about economic benefits of the cloud, so let's dig right in. In just about every conversation about computing systems, someone's going to bring up the term high availability. But what exactly does the term high availability mean? Well, to understand high availability, we first have to define availability itself. When we say that an application is available, we simply mean that the application and the systems that it uses are accessible by users. That's it. It's pretty simple stuff. Availability is measured as a percentage of availability over a specific period of time. But there really isn't an explicit definition of what constitutes high availability. In a general sense, high availability means that an application and its systems are accessible most of the time, usually in the high 90 percentile over any given period. So what exactly are the things that can impact availability? Well, it's a pretty long list actually, but some of the more common causes for availability issues are a network outage, an application failure caused by code defects or maybe configuration issues with the application, a system outage, like maybe an outage of a virtual machine that's hosting an application. A power outage, obviously, can cause availability problems, and a problem with one or more reliant systems, such as a database that an application uses. Cloud providers provide a service level agreement, or an SLA, for cloud services, and an SLA specifies the availability percentage of a service, and the cloud provider guarantees that that service will meet that SLA. If it doesn't meet that SLA for a reason that is within the control of the cloud provider, customers are usually entitled to some level of refund for that service. Now, we'll talk more about SLAs in Lesson 14, but for now, let's move on to some other cloud concepts, specifically scaling and elasticity. The cloud can save you a lot of money versus buying all of your own infrastructure, but even so, computing resources aren't free, and you pay for what you use. That's why you want to make sure that your cloud applications are using only the resources that they need. Well, that's easy enough to say, I guess, but resource needs can change quickly and often. So your application might be running on one virtual machine without any problems, but imagine what would happen if your application appeared on the evening news and the number of users that hit your application skyrockets. What do you do then? Well, the cloud offers the ability to scale your application so that it can handle those additional resource needs. Now, if you just need to handle more users, like in our news broadcast scenario I just talked about, you might just need to add additional virtual machines to run that application, something that the cloud makes really easy. This process of adding additional resources is known as scaling out, or horizontal scaling. So for example, your one virtual machine that was running your application is scaled out to multiple virtual machines running the same application. Now, in some cases, you may need additional power So for example, you might find that the virtual machine running your application is maxing out the CPU or maybe using too much memory, and you want to scale to a more powerful machine. That kind of scaling is referred to as scaling up or vertical scaling. And scaling up doesn't add resources. Instead, it replaces your resources with a more powerful resource that has added capability. This kind of easy scaling based on an application's metrics is called elasticity, and it's one of the benefits of moving to the cloud. It also provides the agility that you need for applications that might have different resource needs based upon usage. And by the way, scaling happens in both directions. So you can scale out when you need more resources and scale back in when you need fewer resources. And also you can scale up to a more powerful resource and then scale back down to a less powerful resources as your resource needs change. So now that we've talked about scaling and how you can react to a changing environment when things are working the way that they should work, what about when things go wrong? Microsoft carefully monitors the Azure infrastructure to reduce any impact of small-scale failures. For example, if your application is running on 2 virtual machines, Microsoft will ensure that those virtual machines are allocated within Azure so that they are unlikely to be impacted by system failures. If one of those VMs fails or becomes unhealthy, Microsoft can easily move you to another healthy VM, and this capability is known as fault tolerance. But what about a larger impact? What happens if there's a large natural disaster, for example, that impacts an entire Azure data center? In this kind of scenario, you need to have a disaster recovery plan in place to ensure business continuity. Most cloud providers, including Azure, have services that will enable you to develop and implement a BCDR plan that meets your specific needs. Up to this point, we've talked about some of the operational benefits of moving to the cloud. And don't worry, you'll learn a lot more about that later on. But let's switch gears a little bit and let's talk about some of the economic benefits. And first, let's talk about what's needed for on-premises applications. Let's talk about the contrast between on-premises and in the cloud. This is the pre-cloud model of hosting applications. So first of all, you need physical computer hardware. And that means not only spending money on the hardware in the beginning, but also spending a ton of money to upgrade hardware from time to time and for any repair expenses to keep that hardware up and running. You also have to spend money on network infrastructure. Think about it. You need to run network cables. You have to invest in network switches and other network appliances. You have to spend money on firewalls and network troubleshooting equipment. There's all kinds of money involved in network infrastructure. You also have to spend money on storage areas for server racks and all of the other IT equipment you're going to need. And all of these expenses are considered capital expenses. And there are a lot of them. I mean, we're talking about big money. Now, let's look at the cloud model of hosting an application. In the cloud model, you rent computing resources from the cloud provider. You don't have to buy expensive equipment, some of which you won't even use to its fullest. This shifts your expenses from capital expenses to operating expenses, and that reduces your costs. It gives you better economies of scale. Now, the cloud provider purchases massive amounts of infrastructure at a reduced cost, and then that reduced cost is passed on to you. That's what we're talking about when we mention economies of scale. In a cloud model, you can adopt a consumption-based model where you use only those resources you need. When you need more resources, You can scale out or up as needed, like we saw earlier. And when those resources are no longer needed, you can scale back in or back down to reduce your costs. Clearly, the cloud model provides a lot of economic benefit. Lesson 2. Describe the differences between categories of cloud services. In this lesson, we'll talk about how you and your cloud provider share responsibility and how that responsibility changes in different models. We'll also talk about infrastructure as a service, platform as a service, and software as a service. And you'll learn when each of these service types makes sense for your needs. There are trade-offs and benefits of each service type, and we'll cover those so that you can make the best choice for your specific needs. We'll also introduce the concept of serverless computing in Lesson 2, so you'll have some foundational knowledge when we cover some serverless Azure services in Module 2. What you're looking at here is called the Cloud Pyramid. It shows the three primary types of cloud services: infrastructure as a service, or IaaS, platform as a service, or PaaS, and software as a service, or SaaS. Now you might be wondering why they're shown in a pyramid. Well, this pyramid shape, as it turns out, is a great way to show the shared responsibility model in the cloud. At the bottom of the pyramid, the widest part of the pyramid, users have more control over their resources. They also have more responsibility for those resources. That's why IaaS shows up at the bottom. So for example, a user who creates an IaaS virtual machine in Azure can then remote into that VM and install software onto it. That user has more control over the resource. However, the user is also responsible for the maintenance on that VM. If an OS update is needed, the user has to install that update. With more control comes more responsibility. Even so, the cloud provider still has some responsibility. They manage the infrastructure, things like the underlying computers that run the virtual machine, the network infrastructure, the physical computer racks that house the hardware, all of those kinds of things. As you move up in the cloud pyramid to the middle, where PaaS sits, you have less control, but you also have less responsibility. At this level, the cloud provider will usually take care of VMs that are running your application. You're just responsible for your application itself. Because the cloud provider manages the platform, PaaS services usually come with a lot of built-in functionality. For example, if you have a website running on a PaaS service in Azure, you can give users the ability to log into that website using their social media account without having to do much more than just flip a switch. At this level in the cloud pyramid, the cloud provider manages everything on the underlying VMs, and that means you have no control over when OS updates are installed. At the top of the cloud pyramid, you'll find SaaS services. At this level, users have almost no control at all, but they also have almost no responsibility. This level is where you'll find services like OneDrive or Outlook.com for email. These services are basically cloud-based software programs that you access using your web browser. You don't know anything about the underlying software, and you really don't even care. If the cloud provider updates the software, you might not even know about it, and if you do, it's usually because they've added new features or something like that. So if you think about it, no matter where an application sits within the cloud pyramid, the user and the cloud provider share some level of responsibility. The cloud provider has the most responsibility at the top of the pyramid and the least responsibility at the bottom of the pyramid. And knowing that is important as you decide on which cloud solution works best for your needs. So with all of that out of the way, let's have a look at IaaS, PaaS, and SaaS at a deeper level. Here's the cloud pyramid again, and this time I've highlighted Infrastructure as a Service at the bottom of the pyramid. In an IaaS service, Microsoft provides the infrastructure to you as a service, and by infrastructure, I mean the underlying hardware the application uses. You don't have to worry about managing any of that infrastructure, but as I said earlier, you do have the responsibility of managing the OS and software that runs on that infrastructure. The most popular IaaS service in Azure is called Azure Virtual Machines. And in this screenshot, you can see an Azure virtual machine and the network properties of that virtual machine. This particular VM is running Windows Server 2016. And because Azure Virtual Machines is an IaaS service, I'm responsible for keeping that operating system updated. I'm also responsible for the configuration of that operating system. And if I break something, it's up to me to fix it. I can actually remote into this VM using remote desktop or other ways. Once I do that, I can interact with this VM just like any computer that I have on premises. The ability to remote into the VM is usually reserved for IaaS services. If you move to a PaaS service, you'll usually lose the ability to remote directly into the underlying VM. When I created this VM, I specified a username and a password to use for the administrator account. However, I can create additional users on this VM as well. And if I supply those users with an RDP file or other connection information, they can remote into this VM. Azure makes that possible by creating network resources along with my VM and setting everything up so that it's connected to the internet. Even though that kind of setup seems complicated, it took me literally less than a minute to create this VM, and that's one of the benefits of using an IaaS service for VMs. If I had to create this VM myself on premises, it would typically take a couple of hours at best, but by creating it in Azure, I complete the entire process in a tiny fraction of that time and without all of that hassle. Now let's look at PaaS squarely in the middle of the cloud pyramid. In PaaS, the cloud provider assumes a lot of the responsibility for the infrastructure, but the application and much of the configuration of that application is my responsibility. So in Azure, a commonly used PaaS service is Azure App Service. In this screenshot, I'm creating a web app that runs in Azure App Service, and I have the option of choosing either Windows or Linux as my operating system. But I don't have the option of choosing what version of operating system I'm using. In this case, Microsoft manages the infrastructure for me. I don't have access to remote into that virtual machine, and if that operating system needs to be updated, Microsoft does that for me on their own schedule. However, I still own my application that's running on the virtual machine, and if my code or my configuration causes problems with availability of the application, that's my responsibility and not Microsoft's. Now let's have a look at SaaS at the top of the cloud pyramid. In a SaaS service, the cloud provider assumes the largest responsibility for the infrastructure, but they also assume responsibility for the software that's running on that infrastructure. SaaS services are usually accessed using a web browser, and a commonly used SaaS service is Office 365. In this screenshot, I'm accessing my Office 365 mailbox in a web browser. I don't have any control over the infrastructure at all in this case. In fact, the infrastructure and the underlying application configuration is completely invisible to me. And while Microsoft does update Office 365 from time to time, I don't even know what's happening. I just open a web browser, I hit the application's URL, and it just works. This image shows a simplified example of an Azure data center. In each data center, Microsoft runs a huge number of VMs that can be used by Azure customers. And at any point in time, only some of these VMs are being used. The other VMs, which I've represented here by gray VMs, are sitting there waiting for someone who needs them. Microsoft will actually let you borrow these unused VMs to run code that can run quickly and return a result. And this concept is referred to as serverless computing. Now, it's important to understand that serverless doesn't mean there isn't a computer involved. It just means you aren't using a computer that's explicitly allocated to you. Instead, you're borrowing one of these unused VMs for a very short period of time. In Azure, you can run your own code serverless using a service called Azure Functions that we'll learn about in Lesson 6. And you can also use a service called Logic Apps, which is also serverless. And we'll talk about that also in Lesson 6. And Cognitive Services is another Azure service that is serverless, which allows you to take advantage of machine learning without having to explicitly allocate your own machine. Now that you understand the different service types, let's look at a comparison of the three and some benefits and drawbacks of each. Let's start with IaaS. First, the benefits. With an IaaS service, you use the infrastructure only when it's needed. If you don't need a VM, you can stop that VM and you won't get charged for it. You also get access to powerful VMs without having to pay for hardware, and that saves you a ton of money. You have access to services that are provided by the cloud provider that can help you to manage that infrastructure in your application. In Azure, this includes things like Azure Security Center, Azure Backup, Azure Log Analytics, and much more. You also benefit from the agility that easy and automated scaling provides, and you benefit from fault tolerance that's incorporated into the way the cloud provider manages the deployment of that infrastructure. A possible drawback of using IaaS is that you must manage the operating system and other software installs yourself. You also manage any of the updates that are required for that operating system and software. Okay, so let's look at PaaS, and again, we'll look at benefits first. In PaaS, the cloud provider manages the operating system and other software installed on the VM. The cloud provider usually provides application frameworks that you can use without having to manage any installation yourself of those frameworks. And PaaS also enables a lift and shift capability. That means you can easily take your on-premises application and deploy it to the cloud without having to jump through a whole bunch of hoops and stand up any infrastructure. PaaS services also offer powerful features that you can enable easily to enhance your application. Those might be things like authentication, powerful logging features, and things like that. Now, possible drawbacks of a PaaS service are, first of all, a loss of flexibility since you no longer control the infrastructure and what's installed onto it. You also have to deal with the fact that the cloud provider may update the OS or other components, and if that creates an incompatibility with your application, it might break your application. Now, to be fair, cloud providers usually give you a heads up before they make changes like that, so you can usually test your application for compatibility before they make a big change. Wrapping this up, let's look at SaaS at the top of the cloud pyramid. SaaS typically operates in a pay-as-you-go model, meaning that you pay for access to the application. You don't have to pay for new versions because you're using that application in a subscription-based model. In SaaS, there's also no management overhead at all. Everything is managed by the cloud provider. And because SaaS applications are usually accessed using a web browser, they're often available on just about any device. Finally, because the cloud provider manages everything for you, you don't need an IT staff to manage anything for a SaaS application. Now, for drawbacks, first of all, you're locked into the use case specific to the software service. And if that doesn't meet your needs, you don't have any way that you can change that fact. Also, if there's an outage, you lose complete access to the application. Now, as you move towards adopting the cloud, you'll need to weigh the pros and cons of each of these service types against your specific needs. Deciding to move to the cloud can be complicated. Some applications are incredibly complex and have dependencies that might be hard to move to the cloud for regulatory reasons or technical reasons. In Lesson 3, describe the differences between types of cloud computing. We'll first talk about cloud computing in general and exactly what cloud computing means. Then we'll talk about the public cloud and when it makes sense. We'll talk about the private cloud and how it differs from the public cloud. And then we'll talk about the hybrid cloud and how mixing public and private clouds can benefit you. At this point, you have an understanding of some of the benefits of the cloud, and you know what the three most common types of cloud services are. But let's zoom out a little bit and talk about the cloud itself. You hear that term thrown around a lot. People will say things like, you should be storing that in the cloud, or, hey, today's computing is all about the cloud. But what exactly does that mean? Well, here I have a computer, just a basic computer like the one you're probably watching this video on right now. If I connect this computer to the internet, I now have a connected computer. But in order to actually benefit from being connected to the internet, I need to be able to connect to other computers that are also connected to the internet. Think about it. Everything you do on the internet relies on another computer somewhere that's also connected to the internet. When you browse to a website, you're seeing content that's stored on a computer somewhere else connected to the internet. And really, you could say you're using the cloud when you do that, assuming we want to say that the cloud consists of many computing resources all connected by a network. But that in and of itself doesn't fully describe what most people think of as the cloud. In order to really be considered cloud computing, you need all the things we talked about earlier, things like scalability, agility, and all of that. As you can see, it can be a little bit complicated to explain just what we mean by cloud computing, but at the most basic level, if you combine computing resources connected by a network that offer agility, scalability, elasticity, and so forth, you have all the makings for cloud computing. So now that we have that foundation set, let's talk about the different types of clouds that make up cloud computing. Let's wrap up Module 1 with a discussion of public clouds, private clouds, and hybrid clouds. Public clouds use infrastructure that's provided by a cloud provider. So everyone who uses the cloud shares that same infrastructure. And while you can have cloud resources like virtual machines that are allocated specifically to you, the infrastructure that that virtual machine runs on is shared with everyone else who uses that public cloud. And for that reason, public clouds are sometimes referred to as multi-tenant environments. In a public cloud, you certainly benefit from the agility the cloud provides, and you benefit from easy and quick deployment to the cloud. You benefit from easy management of cloud resources, and as we've already seen, there are a lot of cost control benefits to using the public cloud. At the same time, there are some drawbacks. You do have some loss of control in a public cloud. How much control you have really relies on where your application sits on the cloud pyramid that we looked at earlier. You might also encounter some challenges related to security and regulatory requirements that your application might have. The public cloud also isn't as flexible as operating your own infrastructure. For example, if you want to host your application on a machine with a very specific configuration, you might not have that configuration available to you in the public cloud. Private clouds use cloud infrastructure that's dedicated to a single company. Private clouds can be hosted on premises using infrastructure that's purchased by that company using the cloud, but it's more common that private clouds are hosted by a third-party cloud provider for all of the economic reasons we've talked about already. Because they are dedicated to a single company, private clouds are sometimes referred to as single-tenant environments. In a private cloud, you benefit from agility, just as you do with a public cloud, and you benefit from having a private network. That might be something that's required for regulatory reasons in your business. Private clouds can also be used without internet access. So, for example, a cruise ship might use a private cloud while at sea to manage complex ship systems when they don't have access to the internet. Private clouds can also help you control costs, assuming you host that private cloud with a third-party cloud provider. However, if you host your infrastructure for your private cloud on premises, that can contribute to a much higher cost of ownership. You have to buy infrastructure and maintain that. Also, to control costs, many companies host their private clouds with a third party, but doing so removes some of your agility to control access to your data, and that might present you with some regulatory concerns. There's a third type of cloud that's becoming more popular as more companies make the move to the cloud, and that's the hybrid cloud. A hybrid cloud is a mixture of both public and private clouds. And in a hybrid cloud, you may have an application that's running in the public cloud, but that application uses resources that are hosted either on premises or at a third-party private cloud provider. For example, you might have a web app that runs on Azure App Service, but that app uses a database that is hosted on premises. A hybrid cloud allows you to keep some systems on premises. That can help you to have full governance over those resources. A hybrid scenario also makes it much easier to support legacy systems that you might be using. For example, your application might be using a database technology that isn't available in the public cloud. So by using a hybrid cloud, you can support that legacy system on premises. You also have full control and governance over any of the data and infrastructure that is hosted on premises, and that might be something that's critical to you for regulatory or security reasons. There are some drawbacks to using a hybrid cloud. Systems that you host on premises will need to connect to cloud resources and vice versa, and configuring that connectivity can be a technically complex thing to do, and it can be hard to troubleshoot when things don't work right. You'll also need to ensure that data hosted on premises and in the cloud is compatible, and that may require some additional development overhead to ensure that all your resources can properly consume your data. And both of these drawbacks are likely going to require that you have additional IT expertise in your company, and that usually means hiring new people or training existing people to meet those challenges. Welcome to Module 2, Describe Core Azure Services. There are 2 lessons in this module, but we'll still cover a lot of ground. In Lesson 4, you'll get a good foundation of how Azure works under the hood and how Azure enables the benefits in the cloud that you learned about in Module 1. In Lesson 5, we'll look at core resources available in Azure. You'll learn about 17 different products in Azure, and that will give you a good feel for many of Azure's offerings. We'll also learn about the Azure Marketplace and how it can make adoption of Azure much easier. Well, we've talked plenty about some general cloud concepts. In Lesson 4, you're going to start learning a lot more about Azure specifically. You'll learn about Azure regions and region pairs, and you'll find out how the Azure infrastructure is built. You'll also learn about availability zones and how they can help you with the reliability of your apps. We'll talk about resource groups and how they can help you manage and organize your Azure resources. You'll learn about Azure subscriptions and management groups. And you'll learn about Azure Resource Manager and how it helps you manage and deploy Azure resources. We'll wrap up the lesson with a discussion of Azure resources in general. When you think of the cloud, what image does your mind see? A lot of people think of the cloud as being a nebulous thing that you can't really even see at all, but that would actually be a mistake. The cloud obviously uses physical computers, and those computers are kept in physical buildings that are located around the world. In order to provide reliable services to people all over the world, Microsoft has created some logical boundaries called geographies. The border of one of these geographies is often the border of a country, and for good reason. A lot of countries have specific regulations around data handling, and it's really not uncommon for a company to feel more comfortable hosting their cloud services inside of the country where they operate. Now, as I sit here recording this video, there are 24 geographies in Azure, and these geographies cover the entire planet. Each of these geographies contains 2 or more regions where Microsoft has built physical buildings that they call data centers. Each region in a geography is separated from other regions by hundreds of miles, and that means that a disaster in one region won't impact services in another region within that same geography. This slide shows a couple of different geographies, the United States geography and the UK geography. Now, within each geography are several Azure regions, and when you create an Azure resource, you can choose which region that resource is created in. As I said before, Microsoft has built data centers in each of these Azure regions. So, for example, here's the central US region. In this region, there are at least 2 data centers, and a data center is a physical building that contains the infrastructure for Azure. These data centers are climate controlled, and they have their own dedicated network infrastructure, and they also have an isolated power supply and power generators in case there's a power failure. All of the network traffic into and out of the data center travels on network cables that are either owned or leased by Microsoft. Even traffic that flows across the oceans travels on Microsoft-owned fiber optic cables that are laid out across the ocean floor. In order to ensure proper disaster recovery, Azure customers should deploy resources to 2 regions. Suppose a large tornado hit the central US region data centers, and that data center, by the way, is in Texas, so that's not something that's out of the question. And let's say that destroyed the computers that are running your VMs. Now, unless you have those VMs deployed to a second region, say the East US 2 region shown here, that could spell disaster for you. But even if you deploy to a second region, you still might have an availability issue if Microsoft happened to update the Azure platform on both of your regions at the same time. To avoid that kind of problem, Microsoft broke out regions in a geography into regional pairs, and a regional pair is a logical container for 2 regions within a geography. When Microsoft needs to update the Azure platform, it performs the update in one region in the regional pair, and only after that update is complete will it move on to the next region in the pair. So that ensures that an Azure platform update won't impact your availability, assuming you deploy your service to both regions in the regional pair. You can see a list of regional pairs by browsing to https://bit.ly/az900-region pairs. To protect your data and applications from a localized problem that might happen at a particular data center, Microsoft created availability zones. And an availability zone is a unique physical location that's within a region, and each availability zone contains one or more data centers. Availability zones aren't available in all Azure regions yet, but in those regions that do offer them, there are at least 3 separate availability zones defined. Because each availability zone contains distinct data centers, they don't share a common water source, a power source, or any of the network infrastructure. So that means if you deploy your application to 2 or more availability zones, you can ensure maximum availability. And in fact, Microsoft guarantees that a service level agreement of 99.99% uptime can be achieved for Azure virtual machines only if 2 or more VMs are deployed into 2 or more availability zones. There are 2 categories of services that support availability zones: zonal services and zone redundant services. Zonal services, such as Azure Virtual Machines, are deployed into availability zones explicitly. Zone redundant services, such as SQL Server databases, aren't explicitly deployed into an availability zone. Instead, you specify to make them zone redundant when you create them, and then Azure takes care of the rest by deploying them into multiple availability zones for you. Remember when I created a VM in the Azure Portal earlier? Creating a VM didn't only create that VM, it also created a bunch of other Azure resources to support that VM. That's actually pretty typical. When you deploy a service to Azure, you're almost never going to end up with one single resource. And to make managing all the resources you have in Azure easier, Microsoft created resource groups. A resource group is just a logical container for Azure resources. And resource groups can help you to manage your Azure resources, and how you organize them in that resource group is entirely up to you. One way resource groups can really help with managing resources is that when you delete a resource group, it deletes all the resources in that resource group automatically. This is a huge benefit if you want to control costs. For example, if you want to create a test VM and a website in order to prototype an application temporarily, you might want to create a testing resource group for those resources. And then once your test is complete, you can just delete that resource group, and all of those testing resources get deleted for you in one operation. If you apply tags to your resource groups, and you'll learn more about tags in Lesson 11, you can see those tags on your Azure invoice, and that can help you with billing. For example, you could tag one resource group for the sales department and another resource group for the IT department, and you'd be able to easily separate those resources on your Azure invoice. Resource groups can also make it easy to redeploy large Azure deployments using ARM templates. And you'll learn more about ARM templates in Lesson 4.6, but basically, you can save out a template of everything that's deployed in a resource group, and you can easily redeploy that in its entirety. It's pretty cool stuff. By the way, you can move resources from one resource group to another, and if you want more information on how to do that, check out https://bit.ly/az900-moving resources. Your Azure subscription is the highest level Azure resource. Every other Azure resource you create is created inside your Azure subscription. Each Azure subscription has a unique subscription ID that identifies it. Each subscription also has limits or quotas that are associated with it. For example, you can have up to 200 Azure storage accounts per region in a subscription, up to 25,000 virtual machines per region, and so on. So let's look at my Azure subscription in the Azure Portal. So here's my Azure subscription in the Azure Portal. Here's my subscription ID, which is my unique identifier for my subscription. And here in the overview blade, which is what opens by default, if I scroll down here, you can see that I have a breakdown of all of my costs by resource. So this allows me to keep a really good view on how much I'm spending. I can scroll down and I can see spending rate and forecast as well. Also here within the subscription blade, I can click on invoices, and that allows me to see all of the different invoices that I've gotten from Azure, and I can download each invoice if I'd like to in order to get all of the details of that invoice. I can also choose to email an invoice to someone else if that person needs to look at that. An Azure subscription is created for you when you first sign up for Azure, but you can also create additional subscriptions, and this is useful in cases where you want to separate expenses. Remember, your Azure invoice for expenses is tied to an Azure subscription. And it's also a way for you to work around subscription quotas since they are applied per subscription as well. So there are several different types of subscriptions in Azure. A free trial subscription provides free access to Azure resources for a limited time, and you can only create one free trial subscription per account. If you've previously had a free trial that's expired, you can't create a new one under the same account. A pay-as-you-go subscription is one where you pay for Azure resources as you use them. You don't pay any costs up front, and you can cancel the subscription at any time. A pay-as-you-go dev test subscription is a special subscription type for subscribers to Microsoft Visual Studio. And this subscription is for development and testing only, and it offers discounted rates on VMs. Now, there are other subscription types that may be available to you depending on what type of Azure account you have. For example, enterprise customers have additional options available to them. So let's go over to the Azure Portal, and let's look at how you can create a new Azure subscription. So here in the Azure Portal, I'm going to click on subscriptions. That will allow me to see the different subscriptions that I have. And I have actually two right now. One of them is active and the other one is disabled. If I want to create a new subscription, I just click Add right here. And then I can choose the subscription type that I want. I have pay-as-you-go and pay-as-you-go dev test. I don't have free trial because I had a free trial subscription a long time ago that since expired, and so that's no longer available to me. Okay, so I'm going to choose pay-as-you-go as my subscription type, and then that's going to take me to the sign up page. And here I can enter in my phone number. This is so that I can be verified by phone. I can enter my payment information for my subscription. If I want to, I can add a technical support plan and read the Azure support agreement. And once I've done all of those things, I can go ahead and create this subscription, and it will be available for me inside of the Azure Portal. And at that point, when I create resources, I can choose which subscription I want to create those under. You've already seen that Azure resources are created in an Azure subscription, and those resources can be organized using a resource group. However, what if you want to organize multiple Azure subscriptions? You can't do that with resource groups because a subscription is actually the parent of a resource group. So if you want to organize Azure subscriptions, you can use another logical construct in Azure called a management group. And unlike a resource group, a management group can only contain Azure subscriptions or other management groups. The true power of management groups is in using them to control who can access specific resources using role-based access control, and that's a concept that you'll learn about in Lesson 10. You can also apply Azure policies to management groups, and you'll learn all about Azure policy in Lesson 11. For now, just remember that a management group is another way to organize Azure resources and apply governance to them. We'll fill in all the blanks a little bit later on. Most applications that are deployed to the cloud use more than one Azure services. You might have a website in Azure App Service, another component running in an Azure VM, and maybe a database running on Azure SQL Database. Complex applications can use a lot more services than that, in fact, and deploying and managing all of these services can get pretty complicated. So to make it much easier to deploy and manage a large number of related Azure services, Microsoft developed Azure Resource Manager, or ARM. ARM is a service that runs in Azure, and it's responsible for all of the interaction with Azure services. So when you create an Azure resource, ARM authenticates you to make sure you have the right access to create that resource, and then it talks to a resource provider for the service that you're creating. Later on in this video, we'll talk about the Azure Portal and using the command line to manage Azure resources. Both of those tools, as well as Microsoft Visual Studio, use ARM to interact with Azure services. ARM provides a consistent and a predictable interface into Azure. So a management tool such as the Azure Portal communicates with the ARM Application Programming Interface, or API, and the API passes the request to ARM. ARM then takes that and passes it off to a resource provider that's specific to the type of resource. ARM also uses what's called a declarative syntax, and all requests to ARM are declared using text files that are in JavaScript Object Notation, or JSON, and those JSON files are called ARM templates. These ARM templates make it really easy to replicate large and complex deployments. You just learned about Azure Resource Manager, or ARM, and how it helps you to create and manage Azure resources. And that's great, but what exactly is an Azure resource to begin with? Microsoft defines an Azure resource as, quote, a manageable item that is available through Azure, end quote. But even that doesn't completely tell you what a resource is. I think the easiest way to understand what Azure resources are is to have a look at some resources in the Azure Portal. And this is my homepage in the Azure Portal. And if I click right here on All Resources, I can see all the resources under my Azure subscription. And I can actually click on one of these resources, say this VM right here. And I can go down here and click on Properties. And right here, I can see all the different properties of this particular resource. I can scroll down here and see all the properties that are associated with it. And I can also see right here a resource ID that's associated with this resource. And that resource ID is how ARM refers to this resource. So I'll go back to All Resources here. So this All Resources view is a little bit misleading because it really isn't showing me all of my resources. We talked earlier about resource groups. And if I go back to the home page of the portal and click right here on resource groups, I see a list of the resource groups under my subscription. These were not displayed in the All Resources view. But each of these resource groups is also an Azure resource. I can click on one of these resource groups, and just like I did with the VM, I can click here on Properties, and I can see the properties associated with this resource group, including a resource ID. And guess what? My Azure subscription is also an Azure resource. So as you can see, a resource in Azure really is what Microsoft says it is. It's an item available in Azure that you can manage. And that means everything you see when you click All Resources. It means resource groups, it means subscriptions and management groups, but it also means things like resource locks, tags, and more. Literally anything that you can manage that is available to you in Azure. Now you've got a pretty good handle on the basics of Azure. So in Lesson 5, we're going to talk about many of the core resources in Azure. We'll cover Azure Virtual Machines for creating VMs using many different operating systems. We'll talk about Azure App Service and how it makes hosting web apps quick and easy. You'll learn about containers and how you can use containers in Azure using Azure Container Instances and Azure Kubernetes Service. We'll also cover using Windows Virtual Desktop to provide users with operating systems and applications in a virtual environment they can access from a web browser. We'll then get into some network topics. You'll learn about virtual networks in Azure, and you'll learn about VPN gateway and virtual network peering for connecting networks. You'll find out how ExpressRoute can offer high-speed connections between Azure and your on-premises networks. We'll talk about storage services in Azure, such as container or blob storage, disk storage, and Azure Files. You'll then learn about the different storage tiers that are available in Azure. Next, you'll learn about database offerings in Azure, such as Cosmos DB, Azure SQL Database, Azure Database for MySQL, and Azure Database for PostgreSQL. We'll wrap up this lesson with a discussion of Azure Marketplace. Now that's a lot to cover, so let's get going. Back in Lesson 2, I told you that the most common IaaS service type in Azure is Azure Virtual Machines. So let's have a look at how you can create a virtual machine, and then we'll talk about some of the features that are available with virtual machines to help you maximize the availability of your cloud applications. So this is the Azure Portal where I can create Azure resources and manage resources I've already created. Keep in mind that the Azure Portal is constantly changing. So when you open the portal today, it might look a little different than this. And in fact, we're going to go through the Azure Portal a little bit more later in this video. Right now, we just want to go over some basics about how we're going to create a virtual machine. So since I want to create a virtual machine, I'm just going to click right here on Create a Resource. And here I can see the popular Azure services, and it looks like Windows Server 2016 Data Center is right here at the top. So I'm just going to click this. Now the first thing I'm required to do is tell Azure which resource group that I want this VM to be in. And I've got a resource group that I already created. It's called AZ-900, and I'm going to just select that here. If I don't already have a resource group for this, I can click Create New, and I can create a new resource group right here at this step. Now I'll scroll down a little bit. This is where I'm going to enter the details for my VM. So the first thing I want to do is give my VM a name, and I'm going to call this My VM. Pretty simple name. I can call this anything I want to. Now another thing you might notice here is that it does validate this machine name to ensure that it's valid. If I enter something here that's not a valid character, it'll automatically fail that validation and show me where that problem is. So it really helps you to not make a mistake at this step in the process. Next thing I need to do is select a region for my VM, and you can see I have a lot of different regions available to me. I'm just going to leave it at South Central US. That's a region that's close to me. I also have different availability options. This is where I could specify to put my VM in an availability zone, but notice availability zone is not available here. The reason for that is because, as I said earlier, availability zones aren't available in all Azure regions yet. And so I can tell here that availability zones are not available in the South Central US region. That doesn't really matter to me right now because I'm not going to select an availability option here. And now I can select my operating system. Notice that I have quite a few different operating systems that I can install onto this VM. For right now, I'm just going to leave it at Windows Server 2016 Data Center. And we're not going to talk about instance size at this point. I'm just going to leave that at the default. I do need to enter in an administrator username and password. So I'm going to enter in James CHE, and I will put a password here. And it needs to be longer than that. Well, let's see. Let's do that one right there. Okay. And they do match. And at this point, I could click Next, and I could select some disk options and go through some other steps to customize how this VM gets created. But for this demo, I'm just going to go ahead and click on Review and Create. And that takes me to this screen, which kind of gives me an overview of about how much I can expect to pay for this and some other information, including the terms. I'm going to go ahead and click Create right now, and that's going to kick off this deployment of my VM, which will take just a few minutes to complete. So Azure is now deploying my VM. Deployment of this VM takes about a minute or so to complete. Azure can complete this process so quickly because it uses containers to deploy these VMs. And we're going to talk about containers more in just a minute. But before that, let's have a look at another feature of virtual machines that can help you with fault tolerance. And that feature is called availability sets. This slide shows my VM hosted on a host computer inside of a physical rack in an Azure data center. This VM is susceptible to downtime due to maintenance events, such as Microsoft updating the host OS, or if Azure moves my VM to another host computer because of a problem. It's also susceptible to downtime if something were to happen in the physical hardware rack where the host computer is located. Now, to protect myself from these types of events, I can use an availability set. When you use an availability set, Azure creates a logical representation of the physical rack, and it calls that representation a fault domain. The fault domain protects you from hardware failures and other faults in the rack. Azure also creates another logical entity called an update domain, and this protects you from VM reboots that might happen due to maintenance events in Azure. Let's look at this in more detail so you can understand this concept a little better. Here you can see 5 Azure VMs, and they're in an availability set. This availability set has 2 fault domains and 3 update domains. Each of these VMs is running the exact same application. They're essentially identical, and I have multiple VMs so that I can take advantage of the fault tolerance and high availability that's provided by availability sets. VMs 1, 3, and 5 are in fault domain 0, and that means they're all hosted on computers that are in the same physical rack in the Azure data center. VMs 2 and 4 are in fault domain 1, so they're hosted on computers that are in a different rack. If VMs 1, 3, and 5 go down because of some kind of problem in the rack where they're hosted, I won't suffer any downtime because I still have the other 2 VMs in the other fault domain. I didn't place these VMs in these specific fault domains myself. All I did was create an availability set, and then I told Azure to put all these VMs in that availability set. Azure took care of all of the rest automatically. Okay, so what about the update domains? How do those protect me from availability issues caused by reboots? Well, suppose Microsoft is rolling out an update to the Azure platform, maybe a security fix or something like that. And that update requires them to reboot the host OS and computers that are in these racks. Because my VMs are in an availability set, Microsoft will only reboot computers in a single update domain. It will then wait for 30 minutes for those computers in that update domain to reboot and stabilize before it moves on to reboot computers in the next update domain. So this same protection applies if my VMs require a reboot due to something that I've installed on them. And by the way, on the right side of this slide, you can see my availability set in the Azure Portal. It shows the status of each VM in the availability set, which fault domain it's in, and which update domain it's in. Now, there are a few things that you need to keep in mind when using availability sets. First of all, you'll need some way to distribute traffic to your VMs. Remember, all 5 of my VMs are identical for resiliency. So let's say, for example, that these VMs are running a website. I'd want to have a load balancer configured to distribute traffic to my VMs, so the load is distributed across those VMs. It's also important to understand that these VMs were all explicitly created. You can't create a single VM in an availability set and then let Azure automatically scale out to more VMs as you need them. To solve these problems, though, you can use a feature called VM scale sets. And when you create a scale set, you just tell Azure how many VMs you want initially, and then you can configure rules based on CPU, memory, and many other metrics that will automatically scale out to more VMs when you need them. You still benefit from update domains and fault domains because scale sets are deployed into availability sets automatically. And because scale sets are also compatible with availability zones, you're also protected from problems that impact an entire Azure data center. We've talked a lot about virtual machines as an IaaS offering. Let's switch gears and talk about one of the most common PaaS services in Azure, and that's Azure App Service. Azure App Service is a PaaS service for hosting web applications in the cloud. This slide shows a high-level overview of how App Service works. When someone browses to a website that's hosted in App Service, and by the way, those websites are typically called web apps, the request first hits an Azure load balancer. That load balancer is responsible for sending the request to one of the many front ends that run in Azure App Service. The front end knows about your web app and which VM it's running on, so it's responsible for sending the request on to the right VM that's hosting your app. The VMs that run App Service apps all run inside of an App Service plan, which is a logical container for one or more VMs that are running your app. You can actually have multiple apps running in the same app service plan, but when you do, all those apps will be running on the same VMs. App service plans can be scaled up for more powerful machines when you need it, and then you can scale them back down to save money. You can also scale out an app service plan to add more VMs and scale back in to reduce that number to save money. So let's have a look at creating a web app inside App Service and how everything works. And the first thing I need to do is tell it what resource group I want to create this in. Let's create a new resource group called AZ-900. And now I have to give my web app a name. And notice under here it says .azurewebsites.net. So whatever name I give my web app, let's say AZ-900 test, which I can't use, let's say test2. All right. So AZ-900 test2.azurewebsites.net will be the URL for this website once I get it created. And I have the choice here of either using code or a Docker container. We're not going to get into Docker containers yet, so let's just use code for now. And I'll select a runtime stack. Notice I can select .NET Core, which actually can run on either a Linux machine or a Windows machine. I can choose ASP.NET, I can choose Java, I can choose Node, I can choose PHP, Python, and Ruby. Not all of these runtime stacks have been here since the beginning of App Service. Actually, Microsoft adds additional runtime stacks all the time and also additional versions. So you'll notice there are different versions for each one of these. So I can, for example, just select PHP 7.3. I can choose to host this web app on Linux or on Windows, either one. I'm going to just say Windows for this one. And the region is Central US, that's fine. And underneath here, you'll see this is my app service plan. And notice it's going to create a new app service plan for me because I don't have one already. If I had an app service plan already created, I can select it from this drop down. And notice here that it calls this a Windows plan. That's because you can't have Windows and Linux machines in the same app service plan. Remember, an app service plan refers to the VMs running your web app. And so obviously you can't have Windows and Linux on the same VM. This is the size that it's choosing. By default, it's just using the standard S1. I can change that if I want to by clicking Change Size. And now I can actually choose a different size for my VM. So if I wanted to say maybe to have this as a test workload, I can actually either choose free or shared infrastructure here, or I can go to a basic. The difference here basically is that free and shared, actually you're hosting your app on the same VM that some other customers are using, and that gives you a reduced cost. Basic is the lowest level that you can use that gives you your own dedicated VM to host your app. So I'm going to apply that. Now you can see that my app service plan is running in basic. I'm going to go ahead and click on Review and Create. That's going to validate that, make sure everything looks good, and then I can click Create to create my web app. And when it does this, it's actually deploying this web app to a VM that Microsoft has already allocated to Azure App Service. So it doesn't have to build the VM itself. It just takes one of those VMs allocated for App Service and it deploys my application that I've just specified to that. So that doesn't take very long to happen, just takes a few seconds. And once that's done, I can click Go to Resource. And this is the Azure Portal management page for my web app. And I can click Browse right here, and that will open a new tab. Notice the URL here is AZ-900 Test 2, just like I said earlier. This is a quick landing page that Microsoft created for Azure App Service. And you'll remember that I said, let's close this real quick so you can see more. Remember that I said you can scale app service, web apps. You can scale out, you can scale up. So I can scale up by choosing this. I can scale out by choosing this. And I also have a lot of other features that are available here because remember, this is a PaaS service. So I get a lot of functionality just right out of the box. So for example, I can click on Authentication and Authorization, and I can just flip this switch to turn this on. And now I can actually configure authentication for my web app using Microsoft accounts, Facebook accounts, and all that kind of thing. So there's a lot of functionality that you get right out of the box with a PaaS service that you wouldn't get if you were to host this by creating a web server and a web app on an IaaS VM. Let's say I want to deploy an application that uses a website and a database. To deploy my application in the traditional way, I'd need to install and configure an operating system on my server. And then I would need to install my application. I'd have to install and configure all of the modules that are necessary for my application. And I'd have to install and configure my database server and my database. And then I'd have to install and configure my web server. And then I'd have to deploy my website for my application. So if I need to install that same application on another server in the future, I have to go back through all of those steps. And if I want to deploy this application to the cloud, I have to go through all of those steps on my VM in the cloud. All that takes a lot of time, and we all know that time is money. So there has to be a better way, and in fact, there is, and it's called containers. A container runs on a computer using special software known as a container runtime, and the most popular runtime is called Docker. To use a container, you first create an image, and the image is really just a compressed file that contains everything that you need for your application. It contains the operating system, the application, all the modules necessary for the app, contains the database server, and it contains the web server and the website. So once the image is created, it can then be hosted in a repository and then easily deployed to any computer that's running the Docker runtime. So you can see why this kind of deployment is so popular. It's a super fast way to deploy an application and also everything that application needs to any environment. If I want to deploy my application and everything else it needs to another computer, I just point the container runtime to my image and I'm done. I don't have to go through all the steps to install and configure everything because my image contains everything already in it. Azure offers many services that can use containers, and one of those is called Azure Container Instances, or ACI. ACI makes it really easy to deploy a container. You just tell Azure where the image is, and ACI takes care of the rest. In this slide, I'm creating an ACI instance using one of Microsoft's Quick Start images. All I have to do is tell ACI which image I want to use and the size of the VM I want it to run on. And after I do that, I'm done. Azure creates the underlying VM to run my image. And what's great is I don't have to pay for that VM. I only have to pay for the CPU and memory that my container uses. ACI is a really great solution for a simple application, but if you're running an application in a container that has a large number of users or that has the need to scale, you're probably better off using another Azure service called Azure Kubernetes Service. Azure Kubernetes Service, or AKS, is an Azure service that provides Kubernetes in the cloud. So what exactly is Kubernetes? Well, Kubernetes is a container orchestration service, and that means it can monitor your containers to make sure they're always up and running. Kubernetes can also scale and add more containers when it's needed, and then scale back in when additional containers aren't needed. A group of related containers in Kubernetes is called a pod, and the containers in a pod can share resources. That's actually one of the advantages to Kubernetes. Normally, when you're operating in a multi-container environment, resources between containers can't be shared, but in a Kubernetes pod, that restriction doesn't exist. However, containers in one pod still can't share resources with containers that are in a different pod. Kubernetes uses computers called nodes or workers, and these are the computers that Kubernetes pods run on. Each of the nodes has to be running a container runtime such as Docker. And this is an important thing to understand about Kubernetes. It's not a container runtime. It doesn't know how to run a container. As I said before, Kubernetes is a container orchestration service. So I just want to be sure that you understand that distinction. All the Kubernetes nodes are controlled by a master node, and that master node is called, strangely enough, the Kubernetes master. All of these computers, the master and all the nodes it manages, make up a Kubernetes cluster. And configuring a Kubernetes cluster correctly requires a lot of deep knowledge of Kubernetes. In fact, configuring the master is one of the most complex things about using Kubernetes. And for that reason, Microsoft offers AKS as a PaaS service so that users don't have to worry about all that complex configuration. AKS not only simplifies the creation of a Kubernetes cluster, but it also makes it really easy to manage the cluster. Here's an AKS cluster in the Azure Portal. I'm looking at the performance of all my nodes, but I can also easily upgrade the cluster or scale the cluster and do more right from this menu within the Azure Portal. Now, this doesn't completely remove me from having to understand some things about Kubernetes, but it certainly makes it a whole lot easier. Today's businesses are embracing the bring your own device model where employees are able to access business applications using their own computers, tablets, and smartphones. However, this model presents some very real challenges to businesses. They have to deal with licensing for software installed on all these devices. They have to troubleshoot applications when things go wrong. And one of the most difficult problems to deal with is employees having sensitive or sometimes confidential files stored on their personal devices. To deal with these complications, many companies are turning to what's called desktop virtualization, where an operating system and applications are installed on one or more centralized computers, and employees run the OS and applications in a virtual environment on their own device. The OS and applications aren't actually installed on the employee's device, but the desktop virtualization environment makes it feel like they are. This sounds like the perfect solution, right? But it's actually really complicated to configure a desktop virtualization environment. So wouldn't it be nice to have desktop virtualization offered in the cloud as a PaaS service? Well, you probably already see where this is headed, don't you? Windows Virtual Desktop is an Azure service that provides a desktop virtualization environment managed by Microsoft. Now, it does require a bit of advanced configuration, but once you've got everything configured, the platform is managed entirely by Microsoft. To use Windows Virtual Desktop, you first create a WVD tenant, which is a collection of one or more host pools. And a host pool is a group of one or more VMs called session hosts, and one or more app groups that represent the OSs and applications that users should be able to access. Once you've set that up, you can give users access to the OSs and the apps using Azure Active Directory and Azure AD Domain Services. Users can access these OSs and apps using the WVD client, and it's available for Windows, Mac OS, iOS, and Android. But they can also use the web-based WVD client using any web browser. So the client allows the user to see a list of OSs and applications that they can use, and when they click on one, it gets launched in a virtual session that makes it look exactly like it's running on their device. WVD also creates a temporary local profile on the device for users to store files while using apps. Azure Virtual Networks, which by the way are usually called VNets, are networks in the cloud. They're software implementations of physical networks, and that means they have all the normal players that exist in a network, like network cards or NICs, IP addresses, and even subnets. I mentioned this earlier, but it's worth repeating. It's really uncommon for a cloud solution to use a single Azure service. You might use a web server, maybe a caching component for added speed, a database tier, and so on. VNets in Azure are really useful in dealing with this kind of a multi-tier application. This image represents a typical multi-tier application. There's a web tier that people use to interact with the application. There's a middle tier that provides some caching service, and there's a data tier that's running a database server. I can separate each of these tiers into its own subnet within my VNet, and that makes it really easy to apply some security practices to how these different tiers can talk to each other. Now, we'll cover that in detail in Lesson 9 when we talk about network security groups, but the important point to get at this stage is that Azure VNets have all the features you'd have in an on-premises network, but these features are hosted in the cloud in a virtual environment. By the way, Azure makes it easy to connect your VNet to other networks, so your Azure resources can communicate with computers you're hosting on premises or even those you're hosting on another cloud provider. Of course, anytime you have to deal with network traffic that's traveling across networks, and especially over the internet, you're likely going to experience a speed bottleneck. That might be a big problem for you, especially if you want to do something like connect an Azure service to an on-premises database and you want a fast user experience for your application. Well, it turns out that Azure has a service designed to solve that problem, so let's have a look at that service now. Think about networks for a second. Obviously, networks allow for computers that are on that same network to communicate with each other. But if that were the limit of connectivity that networks provided, they wouldn't be very useful. Networks really need to be able to connect to other networks in order to provide, well, networking. For example, the Azure VNet shown here might have some VMs or other resources in each of these subnets, and it's great that the VNet enables those resources to talk to each other. But I might also want to connect this to an on-premises network. Maybe I've got a database or other system that's running on premises, and I want to connect it to Azure. Now, if I simply configure connectivity directly to my on-premises network, that does meet the basic requirement, but is this really secure? Keep in mind that this is going over the internet, and if I really want to meet security requirements, I'd never choose this option. Instead, I can choose to use Azure VPN Gateway to create this connection. And when you create an Azure VPN Gateway, Azure creates a subnet in your VNet called a gateway subnet. And that subnet has 2 or more VMs in it that run some services that enable the functionality of VPN Gateway. They also have information that tells them how to route network traffic. So once you've created a VPN Gateway, you can securely connect to your on-premises network using an encrypted virtual private network tunnel. Now, you can't connect to the VMs that run in the gateway subnet. They're controlled by VPN Gateway, and they're not designed for any other use. Once you've created your VPN Gateway, you can use it for 3 types of connections: VNet to VNet connections, which allow you to securely connect from one Azure VNet to another Azure VNet. This is useful when you want to securely connect 2 VNets that are in different Azure regions. You can also configure a site-to-site connection where you connect one network to another network. The on-premises example that I used earlier is an example of a site-to-site connection, and technically a VNet to VNet connection is also a site-to-site connection. This type of connection does rely on a VPN appliance at the on-premises network, and you also need an externally facing IP address. You can also configure a point-to-site connection, and this is where the connection to the Azure VNet is configured for a specific computer or device. This solution doesn't require a VPN appliance. Instead, it uses the VPN client that comes with Windows or comes with another operating system. So the computer that's connecting to your Azure VNet simply needs internet connectivity. Now, it's worth mentioning that VPN Gateway is billed by the amount of time that the gateway is provisioned and available. You aren't charged for network traffic. However, you will incur a small hourly charge per VPN tunnel. Another important point is that VPN Gateway does have bandwidth restrictions, so you'll need to make sure that your traffic can live with that constraint. And a final important consideration is latency. VPN Gateway is not designed to be low latency, so if your application is sensitive to network latency, you might want to go another route. Let's talk about VNet peering. Here I have a couple of VNets in Azure. Now let's assume that I have some Azure resources in each of these VNets that need to talk to each other. How can I make that happen? Well, I could set up VNet to VNet connectivity with a VPN gateway, as we saw in the previous lesson. However, if I do that, I have to recognize that there are bandwidth restrictions and latency concerns, the things we pointed out when we talked about VPN gateway earlier. By default, any network traffic that's going to an IP address that's not within the IP address range of that VNet is going to be sent over the internet. That means that if I have a VM in VNet 1 and I want to allow that VM to communicate with a VM that's in VNet 2, that traffic is going to go over the internet by default. And really, that's no good. If that traffic goes over the internet, it's going to be susceptible to slowdowns and all kinds of other problems that are out of my control. Now, if I want to avoid that, I can use a feature called VNet peering to connect my virtual networks. When you use VNet peering, traffic between the VNets travels over Microsoft's internal backbone infrastructure, and that means that I get low latency and high bandwidth between my VNets. In fact, using VNet peering, the latency between two VMs in two different VNets is the same as if those VMs were in the same VNet. Virtual network peering connects VNets that are in the same Azure region, but you can also connect VNets that are in separate Azure regions using global peering. Now, there is a restriction you need to be aware of. You can't peer two VNets that have an overlapping IP address range. That makes complete sense, but I did want to mention it just in case. Now, if you're using global VNet peering, and remember that means peering two VNets that are in different Azure regions, you can't connect to resources through the front-end IP address of Azure Load Balancer that's running in the basic tier. You'll need to use the standard tier of Load Balancer instead. But in some cases, that's not possible because an Azure resource might be using basic Azure Load Balancer internally, so you can't control which tier is being used. This is the current list of Azure services that use basic load balancer as of this recording. If you're using one of these services across VNets that are using global VNet peering, you won't be able to connect to them using the front-end IP of the load balancer. You can connect directly to your resource's private IP address as long as that's something that's allowed in your given configuration. If you need to connect an Azure VNet to your on-premises network, what kind of speeds can you expect? Well, truthfully, if your network traffic travels over the internet, the answer to that question is it depends. Not only is the internet highly unpredictable, it also represents a security risk. To address these concerns, Microsoft provides a service called ExpressRoute. ExpressRoute can provide you with speeds up to 10 gigabits per second and up to 100 gigabits per second if you use the much more expensive option of ExpressRoute Direct. All ExpressRoute traffic travels over dedicated fiber optic connections, and you connect directly to a network device on the edge of Microsoft's network called a Microsoft Enterprise Edge Router, or MSEE. When you use ExpressRoute, you usually connect using a third-party service provider that has that direct connection to the MSEE. This image shows a high-level view of an ExpressRoute connection. There's a direct connection from the on-premises network to the third-party service provider. That direct connection doesn't use the internet. It's literally a direct connection to the service provider's network. The service provider then has a direct connection into the MSEE running on the edge of Microsoft's network, and that MSEE has a direct connection into Azure. The connection between the service provider and the MSEE is called an ExpressRoute circuit. Now, the configuration you see here can provide you with speeds up to 10 gigabits. So way faster than what you'd get using something like a VPN. A VPN is going to give you max speeds of about 1.25 gigabits. You're also gaining security because none of your network traffic goes over the internet. But this setup does mean that you're trusting the third-party service provider with your data. In most cases, that's not a problem. But if your security requirements demand that you not send your network data through a third-party service provider, you can use ExpressRoute Direct. And when you use ExpressRoute Direct, your on-premises network is connected directly to a physical port on the MSEE in Microsoft's network. That kind of connection gives you speeds up to 100 gigabits, but that connection's also going to cost you a lot more money. You have to weigh the pros and cons and decide on the best solution for your needs. All right, let's switch gears a little bit and talk about some of the storage options that Azure provides. Azure Storage is a service for, well, storing things. What kind of things are we talking about? Well, all sorts of things. For example, you might need to store some graphic files, maybe some video files, or maybe some documents that your application needs. Or you might want to store what you want to make available for users when they're using your application. To store that kind of thing, Azure offers a service called blob storage, sometimes referred to as container storage. Blob storage stores things in an unstructured way. In other words, it's designed to store all kinds of files, or what blob storage calls blobs. There are several different types of blobs. Block blobs are simply blobs used to store any type of file. All the examples I stated previously would be good candidates for a block blob. Append blobs can also store any type of file, but they're blobs that are specialized for append operations where information is frequently getting added to the blob. So for that reason, a lot of people use append blobs for things like storing diagnostic logs that are constantly being updated. Page blobs are also specialized, and they're used for storing virtual hard disks or VHD files that are used in Azure virtual machines. All blobs in blob storage are stored in what's called a container. Now you can use containers to organize your blobs. You might have a container for video files, another container for documents, that kind of thing. Really, the choice is completely up to you. There are a lot of ways that you can move data to Azure Storage. Microsoft offers a free tool called Azure Storage Explorer that you can use to upload data to blob storage. You can also use command-line tools to do the same thing. However, if you need to move a lot of data to Azure Storage, you're going to want to use a service that Microsoft offers called DataBox. It offers an online component called DataBox Edge that makes copying things to blob storage as easy as copying files to a hard drive. If you have a huge amount of data that you want to move into blob storage, you can use the DataBox offline service. And when you use the offline service, Microsoft actually ships hard drives to you, and once you get them, you just copy all of your data to those drives, and then you ship them back to Microsoft. And Microsoft then copies them to your blob storage. They can even ship you a rugged device that's actually sitting on wheels that will allow you to easily transfer up to 1 petabyte of data to blob storage. When you create an Azure virtual machine, a disk is created for temporary storage. If that VM gets rebooted, anything stored on that disk is gone. If you want persistent storage for a VM, you can use a disk that's stored in a page blob in Azure Storage. And these disks are commonly referred to as Azure Disk Storage or simply Azure Disks. Azure disks can be either standard hard drives or solid-state drives. Now, HDD drives are cheaper, and they're designed for data that's not critical. The SSD disks are more reliable, and they come in 2 different tiers. They come in standard tier for light use and premium disks for heavier use. You can create an Azure disk as either a managed or an unmanaged disk. Both are backed by page blobs and Azure Storage. But the difference is that unmanaged disks use an Azure storage account that belongs to you and that's in your Azure subscription. And that means you have to manage that storage account. And it also means if you experience heavy disk usage, you might have downtime because Microsoft might throttle that storage account. When you use managed disks, the page blobs are in a storage account that Microsoft owns and manages, and that means you no longer have to worry about managing the account, and you won't be throttled if there's heavy usage. Microsoft actually recommends that anyone using unmanaged disks move to managed disks, and if you create a new VM, it's recommended that you always use managed disks. Azure disks seem like a great way to store files in the cloud, but in order to use an Azure disk, you need to also create an Azure virtual machine. What if you want to store files in the cloud, but you don't want to have to pay for a VM? Well, as it turns out, you can do just that by using another Azure service called Azure Files. Azure Files is simply disk space that's in the cloud. It's a managed server message block, or SMB solution, and because SMB is a standardized protocol, that means you can use Azure Files with any computer or device that can use an SMB file share. In other words, you can copy files to and from Azure Files just like you would any other hard drive. It really is that easy. Okay, easy, yes, but what about speed? I mean, after all, Azure Files is in the cloud. Any files you copy are going to have to travel over networks, and that could be slow. Well, to solve that problem, you can use Azure File Sync. Azure File Sync uses a Windows server or a Windows Server cluster to sync all the files in Azure Files locally, and it does this using a service called Storage Sync Service in Azure. And a service also is on your Windows Server or Windows Server cluster, and that's called File Sync Agent. You can actually sync your files on as many servers as you want, so if you have a lot of servers all over the world, you can create cached copies of Azure Files on as many of them as you want so that users will always have really fast access to files no matter where they are in the world. All right, let's talk a minute about the different storage tiers that are available with blob storage. There are 3 storage tiers that Microsoft offers, and they're priced according to how often you access data and how long you store that data in blob storage. The hot tier is for data you need to access often. It does have the highest storage costs, but it has the lowest cost for accessing data. The cool tier, on the other hand, is for data you intend to store for a longer time, but that you don't need to access as often. It has a lower storage cost than the hot tier, but the access costs are a little higher. In the cool tier, you are required to keep data in storage for at least 30 days. The archive tier is for long-term data storage. Data in the archive tier has the lowest storage cost of any of the tiers, but the access costs are the highest. You have to keep data in the archive tier for at least 180 days. If you take data out prior to 180 days, you can be charged a fee for early removal. It's also important to realize that accessing data in the archive tier can be slow. In the hot and cool tiers, Microsoft guarantees that you'll get the first byte of data within milliseconds. But in the archive tier, you're guaranteed access to the first byte within 15 hours. We've covered how you can use Azure to store files, but what about storing data that isn't in a file format? There are actually quite a few database services in Azure that are great for that, so let's have a look at those, starting with a service called Azure Cosmos DB. Cosmos DB is what's called a NoSQL database system. That means it stores data that's not structured. Say, for example, you want to store a list of all your company's customers. In a structured database system, each customer record you store would have to comply with the structure of the database. The database would require that certain fields be included with each customer, and if you wanted to store additional information about a particular customer, you'd have to modify the structure of the database in order to allow that information to be stored. In a NoSQL database, because the data isn't structured, the database doesn't impose those kinds of restrictions. So in other words, if you want to store the type of car that one of your customers drives, you can do that without having to do anything special. The database doesn't really care about what type of data or what fields you're storing. There are 4 different types of NoSQL database systems. In the key value system, your data is tied to a unique key. You pass in the key, and the database returns the value that's associated with that key. The key and the value can be almost anything, and because of that, the key value system is a good general purpose system. In the column system, data is stored in columns and rows, but each row can have its own set of columns. Because of that, you're not locked into a particular schema. This kind of system is useful for storing something like user profile data for a website, and because column system databases are very fast and scale really well, they're also great for storing large amounts of data. The document system stores data in a structured string of text called a document. That document could be HTML, JSON, and so on. Document system databases are similar to key value system databases, but unlike the key value system, the document system isn't structured. The graph system stores data in the relationships between each piece of data. In a graph system, data is stored in what are called nodes. This kind of system is great for things like social networks because it can store the relationships between people, all the things those people like, and things like that. In order to make it easy for users to start using Cosmos DB without having to make a lot of changes to an application, Microsoft offers many different application programming interfaces, or APIs, that you can use with Cosmos DB. When you create your Cosmos DB database in Azure, you select which of these APIs you want to use, and your selection is going to be based on which database system your existing application currently uses, or the database technology that your developers already know. The core, or SQL API, allows you to query a Cosmos DB using the common SQL syntax. And this is a great choice for users who might be familiar with using relational databases. The Cosmos DB for MongoDB API is for users migrating from MongoDB databases to Cosmos DB. And MongoDB is a popular document database. The Cassandra API is for users migrating from a Cassandra database to Cosmos DB, and Cassandra databases are column databases. The Azure Table API is for migrating data stored in Azure Table Storage to Cosmos DB, and this API is used with a key value database. And finally, the Gremlin API is for migrating Gremlin databases to Cosmos DB, and Gremlin databases are graph databases. Now, another huge advantage to Cosmos DB is what Microsoft calls turnkey global distribution. You can use turnkey global distribution to horizontally scale your Cosmos DB with just a few clicks. In this screenshot, you can see a map of the world in the Azure Portal, and a blue icon appears in every region where Cosmos DB is available. You can scale your Cosmos DB to any of these regions by simply clicking on it in the Azure Portal, and that means you can ensure that users have the fastest experience possible no matter where they are in the world. Azure SQL Database is a managed offering that provides SQL Server in the cloud. And SQL Server is a database system from Microsoft for storing structured relational data. Each database in SQL Azure Database contains one or more tables of data, and they usually contain multiple tables that are related to each other. For example, you might have a customers table that stores all your customers, and an orders table that stores all orders that customers have made from your online store. You can run queries in Azure SQL Database that join data from multiple tables based on these relationships. Let's look at an example to make this concept a little clearer. Here's an example of the customers table and the orders table I was talking about a second ago. Notice that each customer in the customers table has an ID associated with them. And notice that the orders table has a customer field that contains the customer ID. Even though the orders table doesn't contain details on each customer, I can get those details by querying the customers table and filtering that query on the customer ID from the orders table. There are a few different deployment options with Azure SQL Database: single database, elastic pool, and managed instance. Let's look at each of these in a little more detail. A single database is a database running in a hosted SQL Server instance that runs in Azure. Microsoft manages the database server, and you're responsible for the database. There are two different purchasing models for a single database: Database Transaction Unit, or DTU, and Virtual Core, or vCore. A DTU represents a collection of CPU, memory, and data access. The vCore model uses a virtual CPU, and you can configure exactly the CPU power, memory, and other resources that you need. The DTU model isn't as flexible as the vCore model, but you get fixed and predictable pricing as a trade-off. It comes with pre-configured limits and storage, CPU, and memory configurations. There are three different offerings in the DTU model: Basic, Standard, and Premium. Now, obviously, you pay more with higher tiers, but you also get more capability. The DTU model also offers backup storage and long-term retention at an additional cost. The vCore model is a good choice if you need high visibility and control of the resources that your database uses. And as I said earlier, it offers flexibility in CPU, memory, and storage configurations. And you're charged for storage by how much you use. vCore offers two levels of service: general purpose and business critical, and you'll get better performance and availability from the business critical offering. In the vCore model, you can scale your CPU, memory, and storage as needed, so that means it offers the scalability and the elasticity that cloud users are used to. And finally, like the DTU model, the vCore model provides backup storage and long-term retention for an additional cost. Okay, now let's look at the elastic pool deployment option. The elastic pool option consists of more than one database managed by the same SQL database server. In an elastic pool, you can easily move databases into and out of the pool, and you can also easily add new databases to the pool. This kind of flexibility makes the elastic pool a great option for a SaaS service where you might want to have multiple users, or maybe even each user have their own database. In an elastic pool, you're charged for the resources used by the pool and not for the individual databases within the pool. You also have full control over how individual databases in the pool use resources, so it's a great way to control costs. The managed instance deployment option is explicitly designed for customers who need an easy migration path from a non-Azure environment to Azure SQL Database. A managed instance is fully compatible with SQL Server on-premises, and because a managed instance database is integrated with an isolated Azure VNet and it has a private IP address, it can sit inside of your Azure VNet. All these elements mean that the managed instance deployment option is ideal for users who need a lift and shift solution from on-premises to Azure without having to make a lot of configuration changes. Microsoft offers both general purpose and business critical service levels with the managed instance deployment option. By the way, to make it even easier to migrate to Azure SQL Database, Microsoft offers the Azure Database Migration Service, or DMS. DMS allows you to specify the databases and tables that you want to migrate to Azure SQL Database, and then it uses a VNet that comes with the managed instance to migrate that data. DMS also sets up synchronization between Azure SQL Database and the original database after it migrates the data. And that means that as long as your original database stays online, any changes you make to it will automatically synchronize to the managed instance in Azure SQL Database. Azure Database for MySQL is a managed service for hosting MySQL databases in the cloud. Like Microsoft SQL Server, MySQL databases are relational databases. However, unlike SQL Server, MySQL is an open source database system. In fact, MySQL is the most popular open source database system in the world. Azure Database for MySQL is a fully managed version of the Community Edition of MySQL. So if you're already using that edition in your on-premises apps, Azure Database for MySQL is fully compatible. Azure Database for MySQL offers a secure environment. In fact, data is secure at rest and in motion. That means that data sitting in your database is secure, but also data that's traveling over networks to and from the database is secure. Microsoft offers several plans for Azure Database for MySQL, from the basic plan to the general purpose plan to memory optimized plans for the most demanding workloads. PostgreSQL is another open source relational database system. It was originally designed to run on Unix or Linux, but it's now also available for Mac OS, OpenBSD, FreeBSD, and also Windows. Azure Database for PostgreSQL is a fully managed implementation of PostgreSQL, and because it's designed to support a very large number of users, it's designed with the enterprise in mind. Pricing for PostgreSQL is similar to the pricing offered for Azure Database for MySQL. There's a basic tier, a general purpose tier, and a memory optimized tier for maximized performance. In Lesson 4, we talked about Azure Resource Manager, or ARM, and the fact that Azure resources can be defined and deployed using ARM templates. And while you can certainly create your own ARM templates, you can also take advantage of many existing ARM templates created by Microsoft and by third parties to deploy Azure resources really easily. Microsoft makes these templates available in the Azure Marketplace that's available in the Azure Portal. So if I click right here in the portal on Create a Resource, it takes me right here to the Azure Marketplace. And from here I can click on one of the categories of items over here on the left, or I can choose from a list of popular Azure offerings. And I can also enter a search term in the search box right here, and that allows me to search all of the Marketplace templates. If I want to narrow down my search even more, I can click on See All right here. And from here, I can still search the Marketplace, but I can also filter by price. I can filter by operating system, or I can filter by publisher. If I find a particular template that I really like and I want to have quick and easy access to it, I can just click right here on this little heart, and that adds it to my saved list. And then I can access my saved list easily by just clicking right here. Now, some of the templates in the Marketplace deploy a single resource, but others might deploy many resources that all combine together to make a single solution. For example, if I scroll down here and I click on Web, here under Blogs and CMS, I have the option of easily creating a popular CMS application in Azure, and each of these will create multiple resources in Azure to support that application. However, when I get my Azure bill, I'll only see the charge for the Marketplace offering I'm using. I won't see a complicated invoice for a long list of resources used by that template. If I want to use one of these templates, all I have to do is click on it, and then I can click Create right here to kick off that process. Now, the Create process differs depending on which template I use, but once I specify all of the required options, I can click on Create here at the bottom, and that finishes off the process. It's that easy. Welcome to Module 3, Describe Core Solutions and Management Tools on Azure. In this module, we're going to continue our tour of the Azure landscape. In Lesson 6, we'll cover the core solutions available on Azure. That includes solutions for IoT, big data, machine learning, artificial intelligence, and much more. And then in Lesson 7, we'll talk about the management tools available in Azure. That includes web-based management, command line management, and even how you can manage Azure resources on your mobile devices. Lesson 6, Describe Core Solutions Available in Azure. This lesson is going to be a whirlwind tour of a lot of Azure technologies. We'll start with an overview of Azure IoT Hub and Azure IoT Central, two Azure solutions for using Internet of Things or IoT devices. Next, you'll learn about how to secure IoT devices with Azure Sphere. Then we'll move into the world of big data with a discussion of Azure Synapse Analytics. We'll talk about managing big data with solutions like HD Insight and Azure Databricks. Then we'll move on to Azure Machine Learning and Artificial Intelligence. You'll learn about cognitive services and how they can make using AI easy, and how Azure Bot Service enables you to create an AI-driven chat experience. Next, we'll talk about serverless computing and two serverless computing solutions in Azure, Azure Functions and Azure Logic Apps. You'll find out how you can manage projects and software development with Azure DevOps and Azure DevTest Labs. And you'll learn about GitHub and GitHub Actions and how they can be used with Azure. I'm sure you've heard about the Internet of Things, or IoT, right? IoT refers to all the devices we use that are connected to the Internet and that are often connected to each other. And there are a ton of these things. In fact, the statistics portal Statista reports that there are more than 25 billion IoT devices connected today. That's billion with a B. And that number is expected to grow to over 75 billion by the year 2025. So to put that into perspective, the population of the entire planet is approximately 8 billion people. In other words, the number of IoT devices completely eclipses the number of humans on this planet. Now, if you're a company trying to manage IoT devices, you've got a complex problem on your hands, but Azure can make it a lot easier using a service called Azure IoT Hub. Azure IoT Hub is a PaaS offering that helps you to manage communication between your application and IoT devices. Using IoT Hub, you can securely send messages to your devices. This is called cloud to device, or C2D messaging. Or from your device to IoT Hub, a process called device to cloud messaging, or D2C. You can also securely route messages to Event Hub, Azure Storage, and Service Bus. IoT Hub supports virtually any IoT device, and it does it at very large scale, up to 1 million devices in a single IoT Hub instance. IoT Hub also makes it easy to manage your devices. You can send firmware updates to your devices using IoT Hub, and you can also set a desired configuration for a device even if that device is offline. When that device then comes back online, it picks up that desired configuration and makes the necessary changes automatically. So let's have a look at IoT Hub in the Azure Portal. This is IoT Hub in the Azure Portal, and I've already added an IoT device to my IoT Hub. So if I scroll down here, I can see that my device is actually sending messages to IoT Hub. That's the device to cloud messages right here. I can also scroll down in the menu and I can click right here to upload a file. Maybe I want to upload a new firmware update. I can click right here to configure message routing. I can use that to send messages from my device to Azure Storage or Service Bus or something like that. If I click on IoT devices, and then I click on my device right here, I can send a message to my device by clicking on Message to Device. And I can also look at the device twin right here. So if I click on Device Twin, I can see a JSON representation of my device. Now the device twin is how IoT Hub can make sure that configuration changes are applied even if the device is offline. Notice there's a desired section. I'll go down here. There's a desired section right here. And then there's also a reported section right here. Now if the properties that are reported from the device don't match the desired values in the desired section, IoT Hub will send configuration to the device so that these two sections match. Now, one thing I can't do within IoT Hub is look at the telemetry that's coming from the device. To do that, I need to configure IoT Hub to send messages to my own application or parse the data from storage or somewhere else I've sent telemetry data to. In other words, IoT Hub is a great way to manage and configure IoT devices, but it's not meant to be a dashboard where I can look at data coming from my device. However, there is an Azure service that will let me do that, and it's called IoT Central. Azure IoT Central is a SaaS offering that makes it easy to configure and to view telemetry from IoT devices. Unlike IoT Hub, IoT Central doesn't require any Azure resources because since it's a SaaS offering, you interact with a pre-existing resource that Microsoft owns and manages using a web browser. IoT Central offers pay-as-you-go pricing, and that pricing is based on the number of IoT devices you have in IoT Central. You can easily create an IoT Central app using any of the templates that are available on the IoT Central website. So with that said, let's jump over to the IoT Central website and have a look at how all of this works. This is the IoT Central website, and notice that you get here by browsing to apps.azureiotcentral.com. Now from this dashboard, I can create a new IoT Central app by clicking on Build right here. And after I click on Build, I can choose a template to start my app. Now notice that there are template types down here that are categorized according to what industry they're in. So there's energy, government, and healthcare. But if I don't see a template there that matches what I'm looking for, I can click right here on Custom, and that allows me to create my own app from scratch. Now, I've already created an app in IoT Central, and I'm going to click on My Apps, and I'll see that app right here. This is for Contoso Farm. I'll click on that, and now I'm in my app in IoT Central. So from here, I can click on Devices, and I can see any devices that I've added. And I actually do have an IoT device right here that's been added to this IoT Central app, and it is sending telemetry right now. So let's have a look at that. I'll click on it. And from this screen, I can scroll down. I can see all the different types of data that I can get from this device. And actually, There's some accelerometer data that's enabled by default. You can tell that from the little eye icon right here. Humidity is actually one of the things that will come from this device. So if I click on this, I can actually get humidity data. I can get pressure data and temperature data as well. And so now I can see all of those are being charted out for me right here on this chart. Now, in addition to the bar graph that we see right here, which is enabled with this button, I can click here to see a table and scroll over here, and I can see the actual data that's coming off of that device. And I can click right here and I can see a map of where all of my devices are in the world right here. Now, my device is not actually sending location data to IoT Central, but if it were, I'd be able to see a little blip here showing me where that is. I can click right here and I can edit the time range that I'm looking at within my bar graph. So notice this is still sending me data right here. I can tell what that data is by the color. The humidity is this kind of greenish color, and then the pressure is actually this red color right here. This is pretty stable data because this is measuring the humidity and barometric pressure right here in the room where I am. Over on the left, you have device sets. This is where you can actually specify a set of devices that meet certain criteria and see all of them in one place. If I want to add a new device, I can go to device templates. Right now I have one device template for the MX chip, which is actually an Azure Dev Kit device that's used for just experimenting with Azure's IoT offerings. And I click that and I can see this is actually the device template itself. You can add additional device templates if you have additional devices. So if you have a device, an IoT device that's not an MX chip device, and you wanted to add that to IoT Central, you would first need to create a device template for that device, and then you can connect your device to it. So Azure IoT Central makes it very easy to add devices, to look at telemetry from those devices, to kind of filter on that telemetry and see only those devices that are important to you, and do many other things with IoT devices in a really easy way without having to develop anything yourself because it's a SaaS offering. Azure Sphere is a solution for securing IoT devices. IoT devices provide a lot of convenience. For example, your smart fridge can tell you when you're running low on milk, and your connected garage door opener can be activated using your smartphone, no matter where you are. However, that convenience does come with a security risk. After all, the last thing you want is a hacker exploiting a vulnerability in your connected door lock and gaining access to your house. So Azure Sphere can help protect you from problems like that. Azure Sphere is built on decades of experience and research by Microsoft. In fact, Microsoft even wrote a white paper called 7 Properties of Highly Secured Devices, and this white paper is the basis for the Azure Sphere ecosystem. Notice that I just said Azure Sphere ecosystem. That's right. Azure Sphere is an entire ecosystem consisting of a microprocessor unit, or an MCU, and that's physically on the IoT device, the Azure Sphere security service that runs in Azure, and the Azure Sphere OS that is embedded into the MCU. So together, these components make up the Azure Sphere ecosystem. In other words, an IoT device has to be manufactured to use Azure Sphere, and Microsoft is partnering with IoT device manufacturers to add new IoT device support all the time. Azure Sphere enforces secure communication between Azure IoT devices, and it also makes it possible for a manufacturer to update IoT devices with new software after they're manufactured. And because Azure Sphere IoT devices run the Azure Sphere OS, which, by the way, is a customized version of Linux, Azure Sphere brings standardization to the IoT world, something it does not benefit from today. Azure Synapse Analytics is a service for doing analysis on big data, And big data simply means more data than you can analyze through conventional means within a desired time frame. So think of it this way. Microsoft offers a service level agreement on Azure services that's in the neighborhood of 99.9%. Now, do you think that Microsoft just throws that number out there and then crosses their fingers that nothing goes wrong? They don't do that. Microsoft maintains a huge amount of data on the underlying Azure infrastructure, and they use that data to predict any problems and react to them before they impact you, their customer. We've already talked about Azure data centers that are all over the world. Just think about how much data Microsoft is collecting on all of that infrastructure. I mean, that surely fits into the category of big data. And analyzing all of that data requires enormous computing resources, and that's exactly what Azure Synapse Analytics provides. Azure Synapse Analytics is actually the evolution of another big data Azure service called SQL Data Warehouse, but Synapse Analytics adds a lot of new functionality. Azure Synapse runs in a cluster, and a cluster is a combination of 4 different components. There's Synapse SQL, Spark integration, and integration of Spark and data lake storage, and then finally Azure Synapse Studio. Synapse SQL is the data warehousing portion of Azure Synapse, which means it's a storage space for data. Using Synapse SQL, you can run powerful queries against your big data, and these queries run on what's called compute nodes. And you can actually have multiple compute nodes running at the same time, and that means you can run multiple queries in parallel. Each compute node runs a component called Data Movement Service, or DMS, and this allows data to move efficiently between the compute nodes. Spark integration represents the integration of Azure Synapse Analytics with Apache Spark. Spark is a third-party big data processing engine, and Synapse Analytics is tightly integrated with Spark. Features that are provided by Spark are automatically added into Synapse Analytics when you create a cluster. Spark is also integrated with Azure Data Lake Storage, a service designed for storing large amounts of data. Data lake storage is designed for any type of data, not relational data. And data stored in data lake storage is stored in containers, with each container typically used to store related data. To make it easy to analyze and manage your data, Azure Synapse Analytics offers a web-based portal called Azure Synapse Studio. Synapse Studio offers powerful query tools that are accessible using the Azure Portal, and you can use these tools to query and analyze all your data that's in Synapse Analytics. HD Insight is a great solution for performing distributed analysis of big data. HD Insight is actually a cloud-based offering of Hadoop, a popular data analytics platform. Hadoop offers the ability to analyze data using queries that are similar to SQL and also using scripting languages. However, HD Insight also offers support for many other ways to work with big data. This includes HBase, which is a type of NoSQL database that's extremely fast and scalable. Storm, a fast and reliable way of processing streams of data in real time. Spark, interactive query for in-memory analytics. R Server for enterprise analytics using R, which is a language specialized for big data analytics. And Kafka for extremely fast processing of huge numbers of data streams, often from IoT devices. All of these systems use clustered computers, and building your own cluster can be time-consuming and difficult. By using HD Insight, Microsoft does all of the heavy lifting for you by creating the cluster for you. HD Insight then performs analytics by breaking up large data into segments and then handing those segments off to nodes that run within the cluster. If you need more power, you simply add more nodes to your cluster. HD Insight doesn't charge for nodes. Instead, you're charged for the hours your cluster is in use. It's pretty common for big data to be analyzed using machine learning, and we'll talk about machine learning soon. But for now, I'll just mention that for data to be analyzed by machine learning, it really needs to be in a form that is optimized for a machine learning model. Azure Databricks is a service that allows you to accumulate and organize data, and then to form that data so it's optimal for a machine learning model or an ML model. Using Databricks, data can be organized, visualized, and even documented using notebooks. And notebooks are a powerful way to present and interact with data, and that data can come from just about anywhere. Now, once you've got your data in Databricks, you can use the Databricks runtime for ML to train machine learning algorithms to analyze the data. Databricks runtime for ML includes many popular libraries such as Keras, PyTorch, TensorFlow, but you can also use just about any other ML library as well. Once your model's been developed, you can export it, which is often called productionalizing the model. You can use either mLeap or Databricks ML Model Export. mLeap is a system that can execute an ML model and make predictions based on that model. And Databricks ML Model Export is designed to productionalize so you can use other ML platforms. Azure Machine Learning is a service that makes it easy to delve into the world of artificial intelligence, or AI. Now, before we go into details on Azure Machine Learning, let's explore a little about AI. In the 1973 edition of Profiles of the Future, the famous science fiction author Sir Arthur C. Clarke said, "Any sufficiently advanced technology is indistinguishable from magic." Now, many people might think of AI as being like magic, but it's actually just math. And as we all know, computers are very good at math. So what exactly is AI? Well, for some people, AI represents a scary view of a human-killing android or some other autonomous machine that's obsessed with ridding the world of humans. Fortunately, that's not what we're talking about when we say AI. When we say AI, we are talking about artificial narrow AI or weak AI. And weak AI is an AI that's capable of performing one specific task much more efficiently than a human can perform that same task. On the other end of the spectrum is artificial general intelligence or strong AI, and that's the AI that you often see depicted in movies and in science fiction books. But that kind of AI does not currently exist, so we can just all breathe a collected sigh of relief. AI uses a digital neural network, and each part of that neural network can communicate and share information with every other part of the network. That neural network takes some input, it processes it, and then it provides an output. Now, the two most common types of input are natural language understanding and machine learning. Natural language understanding is AI that's designed to understand human speech. Think Amazon Echo or Siri. Machine learning, on the other hand, can be used for many applications, but one of the most common is image recognition. Open the Photos app on your phone, for example, and search for ocean, and your phone will show you all your pictures that were taken at the beach. You don't have to tell it which pictures have the ocean in them. It knows already because of machine learning. As you might have already guessed, machine learning relies on big data in order for any machine learning model to work, and it has to be trained and improved using huge amounts of data. For working with big data and building machine learning models, Azure offers Azure Machine Learning. Azure Machine Learning uses the popular Python and R languages for building models, and you build your ML models in an Azure Machine Learning workspace. There are two editions of Azure Machine Learning, the Basic Edition and the Enterprise Edition. The Basic Edition only offers access to machine learning software developer kits and to notebooks. The Enterprise Edition adds many more features, including a drag-and-drop interface for building machine learning models called the Azure Machine Learning Studio. If everything we've talked about up to now regarding machine learning models seems too complicated, you're in luck. Microsoft offers an entire collection of machine learning solutions that you can use without having to develop your own, and they call these solutions Azure Cognitive Services. Azure Cognitive Services are basically SaaS machine learning models, and there are many services that are offered. Computer vision is a service that makes it easy to build a machine learning engine that can do things like recognize objects and images, and it can also do things like recognize inappropriate content in an image. The Video Indexer API can look at video content and do things like automatically add closed captioning in multiple languages or recognize people in videos. It can also do things like search for videos that contain specific words or people or even specific emotions. The Speech Translation API provides language translation in real time, and the Text Analytics API can recognize user sentiment in text. Finally, the Personalizer API makes it easy to provide users with a personalized user experience. One of the most common uses of cognitive services is in building a natural language interaction using AI. I'm sure you've used a lot of these. When you call your internet service provider and an automated phone system asks you to describe your problem, you're using an AI service that understands language. Just about every company on the internet these days offers some type of AI chat service where you can interact with a bot that can help you to interact with the company. You can create your own automated bot services in Azure using Azure Bot Service. Azure Bot Service runs on Azure App Service, and in this screenshot you can see the test screen for a bot service app. In this case, the bot is designed to make flight reservations, and you can see that I've tested an interaction with the bot using natural language. All my input is being sent to Cognitive Services, and the AI engine is processing that input and providing output in the chat window. You can connect Azure Bot Service to many popular services such as Slack, Facebook Messenger, Microsoft Teams, and more. And that means you can quickly create an automated bot that users can consume through many different popular services. However, you can also use what's called Direct Line to connect your bot to your own application or website. Azure Functions is a service that allows you to run trigger-based code in a serverless environment. Apps that use functions, which by the way are usually called function apps, run on Azure App Service, but because they're serverless, they don't require a VM in App Service that's allocated for your use. You can control a function app using daily quotas. Once you reach the quota, Azure will stop the function app until the next day. And this allows you to control costs that are associated with your app. Functions offer multiple different runtimes, which is basically the underlying engine that Functions uses. You can choose the runtime version yourself so that your app doesn't break if Microsoft releases a new update to the runtime. A function app runs when a particular trigger happens, and that could be anything from a file being copied into Azure storage, a time interval being hit, and so on. The function then runs some code and it provides some kind of output. And then you can use output bindings to perform complex operations like call a URL, drop something into Azure storage, trigger an Event Hubs event, or something like that. You can actually configure more than one output binding, so you can create very complex workflows with Azure Functions. However, for really complex workflows, there's another Azure service that's probably a better choice, and that service is called Logic Apps. Azure Logic Apps are similar to function apps, but when you're using a Logic app, you don't have to write any of your own code. Instead, Logic Apps use a drag and drop interface for building serverless workflows. Logic Apps use connectors, triggers, and actions for workflows. A connector is a component that connects your logic app to something. That could be another Azure service, an FTP server, a web server, or a third-party service. A trigger is a specific action that causes your logic app workflow to run, and an action is what your logic app does in response to that trigger. Now, under the hood, logic apps workflows are built using JSON files, and because you can have multiple actions chained together in a single workflow, you can create some really complex workflows. For example, suppose you have an e-commerce website, and when a customer places an order, you want to update your inventory of that product, generate an invoice for the customer, and email the invoice to the customer, and sign the customer up for a newsletter, and finally generate a shipping label for that order. You can do all of that in a single logic app workflow, and you can do it all without writing any code. So let's flip over to the Azure Portal, and I'll show you what Logic Apps is all about. Here is a Logic app that I've created previously in the Azure Portal. And from here I can click on Logic App Designer, and that will take me to the designer where I can create workflows in a drag and drop interface. So I'll scroll down a little bit and notice that the very first thing we start with is a trigger. So I'm going to choose recurrence trigger. A recurrence trigger will actually trigger my Logic App workflow on a regular schedule. So I'll click that, and notice by default it's 3 minutes. That's totally fine with me. So every 3 minutes this is going to trigger a workflow. Now I need to create a next step. So I'll click New Step. And now notice I'm choosing an action. So this is actually what action I want to take when that recurrence trigger happens. Now I can choose from one of the recommended actions here, but for this example, I'm just going to click on Built-in, and I'm going to click on HTTP. I'm just going to choose HTTP here. And now I can choose the method. This is the HTTP method, so I'm just going to choose GET. And this is the URL that I want to get hit when my Logic App workflow runs. So I would specify my site in here. I can actually specify some, let me hide this. I can specify some headers, query strings. I can put in the body of my request right here. And once I'm satisfied that everything is the way I want it to be, I can go down here and create another new step. So this is what I'm talking about when I say you can chain different actions together in a Logic App. Once everything's done, I can click on Save right here, and it will save this workflow. And by the way, earlier I told you that under the hood, Logic App workflows are created using JSON. And you can actually see that by clicking Code View right here. And you can see that this is the workflow that I just created within the Logic App Designer. When large teams, and actually even smaller teams, need to work together on complex tasks such as software development, keeping everything coordinated and running smoothly can be a tough job. Azure DevOps is a service that can be used to help track, plan, and manage many different types of projects, including software development. There are actually multiple tools offered by DevOps. They include Azure Boards, Azure Repos, Azure Pipelines, Azure Test Plans, and Azure Artifacts. Azure Boards is a powerful way to visually track projects and management work using a convenient drag and drop interface. Each tile that you create in Azure Boards has an underlying work item in DevOps that you can use to track all the details on that tile. This image shows Azure Boards in action as I used it to track the work on the second edition of my AZ-900 exam ref book. And notice that there are columns for new items, active items, and completed items, and I can easily drag tiles and drop them into specific columns to track the status of that work. Azure Repos is a source and version control system for source code. It can use either Git, which is an open source version control system, or Microsoft's Team Foundation version control. Now the image here shows a source file in Azure repos, and notice that I have links at the top of the file for history and compare. These allow me to see different versions of a file so I can track how that source is changing. Azure Pipelines is a continuous integration and deployment, or CI/CD solution. It can automatically integrate changes into an application and then build the application with that integrated source code. You can also use Azure Pipelines to implement automatic testing in order to reduce software bugs. Azure Test Plans provides features that make it easy to create complex tests to test for software problems. These tests are often based on work items that are in DevOps that might contain details on a software bug. Once a test has been created, you can run it within Azure Test Plans in a web browser, and that means that tests can be run on any device. Azure Artifacts can help you organize artifacts, and artifacts are packaged components that can be either from the developer's own organization or from a third party. It then integrates these artifacts into the build process, and because Azure Artifacts integrates with Azure Pipelines, it's easy to ensure that your build process always contains the correct artifacts that your app needs. As we were looking at DevOps, we talked a little bit about testing. A common test scenario might involve a developer creating a VM, configuring the VM with the packages and the software needed to perform the test, and then configuring the setup of the VM and software on it to run that test. Now, testing using this method does have some drawbacks. First of all, it can take a long time to create a VM and install and configure everything you need on it. It's also possible that the developer might create an expensive VM that has a lot of power and then forget to delete the VM after the test. That can end up costing you a lot of money. So to solve these kinds of problems, you can use Azure DevTest Labs. DevTest Labs makes pre-configured VMs available for testing. And when you need to use one of those VMs, you claim it, which is kind of like checking out the VM. While you've got that VM claimed, no one else can use it. DevTest Labs uses base images, custom images, and formulas. A base image specifies things like which operating system is used and any artifacts that you need. A custom image is a DevTest Labs image that's based on an existing VM. A formula is also based on an existing VM, but it also contains settings that are specific to DevTest Labs, such as the size of the VM, included artifacts, and things like that. To help save money, DevTest Labs has an auto shutdown capability that will automatically shut down VMs after a certain period of time. When an Azure VM is shut down, billing on it stops, so this feature can end up saving you a lot of money over the long haul. You've learned about Azure DevOps and how it can help software development teams work together. Most software development teams use a version control system, and the most popular open source version control system is called Git. Teams that use Git will also often use GitHub, and GitHub is a web portal for hosting software, documentation, and more. The underlying system behind GitHub is Git, and because of the popularity of both Git and GitHub, many other websites and systems integrate directly with GitHub. So let's head over to GitHub and I'll show you how it works. So as you can see here, to get to GitHub, you just browse to github.com. Now I've logged into my GitHub account, and over here on the left, I can see my GitHub repositories, and a repository is just a centralized place where files are stored that are related to each other. And most people will refer to them as simply repos rather than repositories. So I can go down here and open this Docker test repo right here, and I can now see all of the files that are in that repo. And if I click on one of these files, I can see when this file was last committed to the repo. And when a file is committed, it just means that some change to that file has been added to the repo. So I can click right here on History, and here I can see all the commits for this file. When a commit happens, you can also include a note to indicate what you changed, and that information will also show here. And by the way, GitHub repos can be private, so only those you want to see that repo can see it. But you can also have a public repo. You can actually use a public repo to create your own app or to learn from other developers. So to search for a repo, I'll just click right here to go back to the GitHub homepage, and then I can enter a search term right here, and that will allow me to search for public repos. So let's say that I wanted to find a random number generator. If I search right here for random number and hit enter, I can see that there are 12,256 repos that match that search term. And if I just click on one of these, I can see all of the files that are in that repo. Now let's say that I want to use this repo and create my own app with it, maybe make some changes to it. All I have to do is click right here to fork this repository. And what that actually does is create my own copy of that repo in my own account. So that gives me the ability to make changes that are my own. Now I could, however, maybe fix a bug in this repo's code and request that the original owner incorporate that fix into their repo by doing what's called a pull request. However, unless I take explicit action, no changes that I make to my copy of that repo will impact the original repo. Now, in most situations when a software development team is using GitHub, they'll implement a system where the repo will automatically build a new version of software when developers publish code changes. And when that happens, they can also kick off all kinds of automated tasks using a feature in GitHub called GitHub Actions. GitHub Actions allow you to create automated workflows, and these are used to automate the lifecycle management of applications. GitHub Actions run on computers that are called runners, and they can consist of Docker containers, JavaScript code, shell scripts, and more. You don't have to write your own actions. There are plenty of pre-made actions available in the GitHub marketplace that's available in GitHub. In fact, there are even GitHub actions that are designed to integrate GitHub with Azure. Lesson 7, Describe Azure Management Tools. Lesson 6 covered a huge number of Azure services, and in this lesson, you'll learn about the management tools that will allow you to create and manage those services. We'll start simple with the Azure Portal, a web-based management tool for Azure. Then we'll move into Azure PowerShell and the Azure Command-Line Interface, or Azure CLI. These command line tools bring some additional power and flexibility to managing resources. We'll then talk about Azure Cloud Shell, a web-based command line tool for Azure, and the Azure mobile app for managing Azure resources from your mobile device. We'll wrap up with a discussion of Azure Advisor for keeping an eye on best practices, Azure Monitor for monitoring metrics and checking on the health of Azure services with Azure Service Health. Creating and managing Azure resources is easy using the Azure Portal. The portal is a web-based management portal for Azure resources. It's fully customizable, and you can even customize it for individual users. Individual parts of the portal can also be customized, and that provides you the kind of flexibility that you might need for specific use cases, as we'll look at here in just a minute. So let's have a look at the portal and some of the features that it offers. To get to the Azure portal, you just browse to portal.azure.com, as I've done here, and that will take you right here to the portal homepage. So, like Azure itself, the portal is ever changing as Microsoft makes improvements and they make interface changes and that kind of thing. So, the portal that you see when you browse there today might not look exactly like you see here, but the functionality is going to be the same. So let's look at a few of the features that are available in the portal. If I go up here and click on this gear icon, that allows me to customize the look and the feel of the portal. And this is where I can choose my default view, which right now is set to home, but I can also choose dashboard. I'll show you that here in just a second. You can also choose your color scheme here, so I can choose between the default, which is selected now, or a darker color scheme or a high contrast color scheme. Keep in mind that any of these settings that you change are actually associated with your Azure subscription. It's not associated with this particular computer, and that means that any changes that I make here are going to apply to the Azure portal on any computer that I use to access it. So the default view in the portal is the home view, as I showed you right here. But if I click on dashboard and then refresh the portal by just clicking Microsoft Azure up here in the corner, that's going to take me to this view, which is the dashboard view. And the dashboard's a great way to get a customized view that just includes what you want to see. Each of the tiles that you see here on the dashboard can be customized. So if I go to one of these tiles here and click on this little button in the upper corner, I can customize that by clicking customize. And now you can see I have this grid view along with the ability to change the size of the tile that I'm editing here. I can remove it from the dashboard, or I can also move it around. So if I wanted this to exist over here, I can just drag and drop it there. And when I'm finished, I just click Done Customizing, and now that change has been saved. I can also create a new dashboard. Right now I'm using this dashboard called Jim's Dashboard, but if I click this button right here, that allows me to actually create a new dashboard, and I'm going to call this one, I'll just call this New Dashboard. And now I have this tile gallery on the left hand side here. I can just drag and drop any tiles that I need on my dashboard, or I can click Add. Dragging and dropping is usually easier because then you can customize exactly where you want that to go. So I'm going to put resource groups right here, and I'm actually going to customize that and make it just a little bit different size here, like that. Then I can scroll down, I can select clock, stick that here. I can go down and look at all of the different tiles that are available here, including Marketplace, which we've looked at earlier, so I can put that here if I want easy access to that. Once I finish getting the dashboard the way I want it, I just click Done Customizing, and now you can see that I'm looking at New Dashboard right here. But I can also switch back over to Jim's Dashboard. So any dashboards that you create, you can very easily switch between them right here using this menu. And that allows you to create dashboards that are specific to a particular use case. So for example, if I go into this AZ-900 resource group that we've been using in some of our demos, and maybe I'll go into, let's see what's in here. Well, I've got a VM right here, so let's go into that virtual machine. And when I go into this virtual machine, notice I've got CPU usage right here, and I'm thinking to myself, wow, I'd like to keep an eye on that. I don't really want to have to drill into this VM to do that, so if I click this button right here, that's actually going to pin that to my dashboard. You can see that pinned to my dashboard. So now when I go back to my dashboard, I also have CPU usage for that particular VM right here on my dashboard. And I can edit this and kind of move this. If I say I don't want to have to scroll down to see that, I'd really kind of like to have that further up here, maybe above some of these other tiles, so that it's really obvious to me. And Done Customizing. So now I have a very clear view, and this is live. This is not a static image. This is actually showing me live data that's updating from that VM. And then if I want to drill into that, I can just click in here and it'll allow me to drill into that more. So that allows you to really get a customized experience with the dashboard. If I want to create a new Azure resource, from the portal, I just click on the menu button right here and I can click create a resource. But I can also scroll down and look at some of my existing resources. So like for example, virtual machines. If I click that, it'll show me the virtual machines that I have. And by the way, clicking on create a resource takes us, as we've seen earlier, to the Azure Marketplace. So as you can see, the Azure Portal is a powerful and flexible way to manage Azure resources. However, there are some situations where you might want to create or manage resources programmatically, or you might want to script operations related to your Azure resources so that you can perform a complex series of management tasks without any interaction. And for those types of scenarios, Microsoft offers other ways of interacting with Azure resources. So let's look at those other options you have that are more geared towards the command line. One powerful way for interacting with your Azure resources is by using PowerShell and the AZ module. The AZ module is a PowerShell module that makes it easy to create and manage Azure resources, and you can even write PowerShell scripts that automate working with your resources. And while many people think that PowerShell is a Windows-only tool, it's actually cross-platform now, and Microsoft makes it available for Windows, Mac OS, and Linux. You don't have to know how to run PowerShell commands for the AZ-900 exam, so I'm not going to go into how you install PowerShell and how you configure the AZ module. However, if you do a quick internet search, you can find Microsoft's documentation that will walk you through that process. It's also detailed in my AZ-900 exam ref book from Microsoft Press. PowerShell commands consist of a verb such as get, new, start, something like that, followed by an object such as AZVM for a virtual machine or AZ web app for a web app. So let's have a look at how that works in PowerShell. So this is PowerShell running here on my Mac. Let's look at an example of how the AZ module works. First, I have to log into my Azure account, which, by the way, you have to do each time that you launch PowerShell. So to do that, I need a couple of pieces of information. I need to know my Azure Active Directory's tenant ID, and I need to know my subscription ID. So let's flip over to the Azure Portal real quick. And if I click right here on Azure Active Directory, I can see the tenant ID for my directory right here. So if I click this button, it'll copy that to the clipboard. So I'm going to do that. And then let's switch back over to PowerShell. And to log in, I use the connect-az account command. So I'm going to type connect-az account, and I'm going to pass it that tenant, which I'm just going to paste from the clipboard right here. That's the tenant that I just got from the portal. Now next I need to know my subscription ID, and that's going to be passed in with subscription. Let's go back over to the portal and grab that real quick. So I'll go to home right here, and I need to pull up my Azure subscription. So I'm just going to, actually if I click right here, I can see I've already pulled it up. But you can also, as I've shown you before, you can search for it. There are lots of different ways that you can get to things in the Azure portal. So these are the subscriptions that I have, and this is the one we're using. Notice the other one over here is disabled. So I'm going to click on this. Actually, this is my subscription ID, but I want to be able to copy it. So I'm going to click this, and just as I did with the tenant ID earlier, I have a button here that I can copy that to the clipboard with. So let's do that. And then back over to our terminal, I can just paste that right here. And that's the command that will connect this PowerShell session with that Azure subscription. So I'll hit enter. And now notice it's telling me to go to microsoft.com/device-login and enter this code. So I'm going to do that quickly here. And that code, I'll paste it in from there. I'll sign in with the Azure account that I want to use, And now it says I've signed in to Microsoft PowerShell. I can go ahead and close this window. I'll do that and flip back over to PowerShell, and now we can see that I am logged into my Azure subscription. Now let's have a look at my VMs that I have in my subscription. If I run get.azvm, I can see the list of Azure virtual machines that are under my subscription, and I can actually perform some operations under these. So if I want to start that VM that's called AZ-900, I run start-azvm. That's the command that I'm going to use. Now I'm going to pass to it the resource group name, and that is AZ-900. The VM name is actually AZ-900 VM, so I'm just going to say -name and then AZ-900 VM. Simple as that. I'll hit enter right here, and now I can see that VM is running. And along those same lines, I can say stop AZVM, and I can pass in the same information here. It's the same VM, obviously. It asks me in this case if I want to perform this operation. That's because if I stop a VM, it's no longer available. I want to make sure I don't do that by accident. If I were scripting this and I don't want to have to respond to a prompt like this, I can also use a -force option, which will prevent it from actually prompting me whether I want to continue. I'm just going to say yes here. And now I see that virtual machine is stopped. So each Azure resource type will have commands that are associated with it. And the best way to learn these commands and find the documentation on how to use them is to browse to aka.ms/azps. That'll take you to the Azure PowerShell documentation. It'll give you details on how to install PowerShell, how to configure it, how to log into your Azure account, and then also a reference for all of the different commands that you have. All right, now let's talk about another command line tool for managing Azure resources, and that's the Azure Command-Line Interface, or CLI. Like the AZ module in PowerShell, the Azure CLI is a command line tool that's used to manage Azure resources. Now, a while back, Azure CLI was the only cross-platform command line tool, but now that PowerShell is also cross-platform, your choice of command line tools for Azure really boils down to which tool you're comfortable with. So let's have a look at the Azure CLI. I'm going to switch over to a terminal window real quick. So I'm here in a terminal window. I've actually installed the Azure CLI. I'm not going to go through the installation instructions here, but you can find them by browsing to aka.ms/CLI. They're going to differ depending on which operating system you're running. Just as I did with PowerShell, I first need to log in to my Azure account. And with the CLI, I do that by entering AZ-login. And when I hit enter here, that's going to actually open a browser window where I can log in. So I'll just select my account. And once I do that, now I'm logged into the CLI. And by the way, this window automatically redirects to the CLI documentation within a few seconds. So if you leave this open, it'll automatically give you quick access to the docs like that. All right. Switch back over here to the terminal, and you can see that I have some output here that shows my subscriptions. This output actually is in JSON format, and you'll see here in a minute that the CLI actually outputs everything by default in JSON. So now that I'm logged in, let's run through the same example that I used in PowerShell. First, let's list my VMs. So to do that, I'll run AZ. Anything that you start with AZ is going to automatically run the Azure CLI. That's how you actually access it from your terminal. So I'll do AZ space VM space list. And that's going to give me a list of the VMs that are in my subscription. And as I said before, you get JSON format by default. This is coming back directly from ARM. And remember, ARM uses JSON, so that's why the output is in JSON. However, For this example, I really want to see the output in a table like I did in PowerShell. It just makes it easier for me to kind of deal with that output and understand what's going on. And so what I'm going to do is run the same command, az space vm space list, but this time I'm going to use the output parameter and I'm going to tell it I want an output in a table. So I'll hit enter here. And now I have the list of VMs in a table format that's a lot easier for me as a human to read. Now let's start this AZ-900 VM like I did in PowerShell. I can do that pretty easily. I just run AZ space VM space start. And like I did before, I'll pass in the name, AZ-900 VM, and I'm also going to pass in the resource group, which is AZ-900, and then I'll hit enter. Now this running that you see right here is not actually my VM. What it's saying is it's running the command I just entered. So I need to wait here for just a few seconds for this to actually start that VM and give me some output. And notice that with the CLI, it doesn't actually show you that it succeeded that command, but if you don't get an error message, it takes you right back to the command prompt. That means that everything is good to go. So this means my VM is now running. So now I can, if I want to stop that VM, I can just run AZ VM space stop. And just like I did before, I'm going to pass the name. And by the way, this is not case sensitive. I used an uppercase VM when I did this before. You don't have to. It doesn't care whether you use the right case or not. So the only thing I've changed here is instead of start, I'm using stop. I'm going to hit enter. And now my VM is stopped. So incidentally, the Azure CLI has a pretty powerful help system. If you don't know a command, you can use --help to get more information. So I can say azvm --help, and that's going to show me all the commands that I can run against a VM. And if I want some details on a specific command, so azvm start, for example, I can just pass --help to that. And that shows me all the parameters I can pass to that command. It also shows me other information along with some examples of command lines. So that's a really good way to figure out how to do things within the Azure CLI. Now let's look at another tool for managing Azure resources, and that's Azure Advisor. As you've seen, using PowerShell and the Azure CLI is a powerful way to manage your resources, but there are some drawbacks. You don't get full functionality by default. Many times you need to install extensions in order to interact with a particular Azure service, and if you need to use multiple machines, you have to install those extensions on every machine in order for your commands to work. Well, there's a pretty cool solution to that problem, and it's called Azure Cloud Shell. If I go up here in the Azure Portal and I click this button, it will launch Azure Cloud Shell for me. So when I first launch it, it authenticates me to Azure and it builds an Azure drive for me so I can persist files. Now, if this is the very first time you launch Azure Cloud Shell, it's going to ask you if you want to use Bash or PowerShell. Bash, which is typically used for Azure CLI commands, will give you a black background, and PowerShell gives you this blue background. And by the way, you can run CLI commands in PowerShell too. Also, you can switch between the two, by the way, right here. So I will confirm and switch over to the Bash Cloud Shell. And notice now I have a black background, so I know very easily that I'm actually in Bash. Now, Cloud Shell, for the drive that it uses to store your files, uses Azure Storage. So if you don't have a storage account connected to it, it's going to ask you to create one, but that's an automated process. It's very simple. Azure Cloud Shell uses that storage account to store my Cloud Shell environment. And that includes things like extensions that I've installed and things like that. That means that no matter what device I use to access Cloud Shell, it's going to be an identical environment. It's going to have all my extensions and everything automatically installed for me. When you use PowerShell or the CLI without Cloud Shell, you first have to log into your Azure account at the command line. You have to do that every time you launch them. You don't have to do that with Cloud Shell. It's automatic. So that saves you a step right there. So from here in my Cloud Shell, I can run any command that I would run in PowerShell or the Azure CLI. For example, I can say AZ resource list -- output table, and this will give me a table of all of my Azure resources. Let me just stretch this up a little bit. So now I see a table of all of my Azure resources. Now at the top of the Cloud Shell window, I have a toolbar, and there are some pretty cool features here. I've already shown you how you can switch between the different shells right here. I can click right here to upload and download files, and any files I upload here, they'll be available to me on any of my other devices. Remember, that's stored in Azure Storage. I can click right here to open an editor, and that will let me edit a file that I've previously uploaded. So if I click right here, notice I can browse through the files that are available up there in my Azure Drive. And if I click one of these, it'll open it here in an editor. I can edit the file right here, and after I make changes, I can hit Control-S to save those changes. If I click this little 3 dots here, I can save there as well. I can also close the editor from here. So next time you need to interact with Azure resources from the command line, give Azure Cloud Shell a try and see if it doesn't make things easier for you. Okay, this might look a little weird. I'm actually not on my computer right now. I'm actually using my iPad. So what exactly is going on? Well, I'm going to show you an app called Microsoft Azure that lets you interact with your Azure resources from your mobile device or your tablet. You can get it from the Apple Store or from Google Store if you're using an Android device. Now, I've already logged into my Azure account, and from the home screen here, I can click on an icon to see my virtual machines, to see my web apps, to see SQL databases, or to see an application insights instance. I can also see alerts here. I don't have any alerts right now, but if I did, I'd be able to see them here. And I can also see resources that I've recently interacted with. So I can click on one of those resources. Let's say this CPVM right here. And now I can manage this resource from my device. So I can see metrics for my VM. And by swiping here to the left, I can see additional metrics. Now this VM is actually stopped right now, so I don't actually see anything. At the bottom of the screen, if I want to start the VM, I can just tap on Start and then tap Start. And now this VM is starting up for me right from my Azure mobile app. I can even connect to this VM using the remote desktop mobile app. I can actually, just as I would if I were sitting at my desktop, I can remote into that VM and interact with the user interface of the operating system. Notice that you don't have all of the options available here that you have in the Azure Portal, but you've still got a lot of functionality here that you get to keep in your pocket. So that's pretty cool. But I am going to show you something now that's really cool about this app. If I click the back arrow at the top there, get back to the home screen here, at the bottom of the screen I have some buttons here. And notice at the far right side, I actually have a Cloud Shell button. So if I tap that, I actually get a Cloud Shell instance right here in my mobile device. That's really cool. I mean, I can run commands here just like I did on my computer. So if I wanted to list out all of my Azure resources like I did on my computer, I just tap here and I type the command. Just like I did on my computer earlier. We're going to change this to a table output instead of JSON. And I'll hit enter. And there are all of my Azure resources. Exactly the same thing I got when I was on my computer. And remember, Azure Cloud Shell persists any extensions that you install. So if I had some extensions installed that I installed from my computer, those would be available to me here. Now, you don't have things like the file editor in the mobile app, but you do have all the functionality you have at the PowerShell and Azure CLI command line. So there's a ton that you can do with this feature. Azure Advisor is a tool available in the Azure Portal that helps you to configure high availability, efficiency, and security. And it does this by offering recommendations in the areas of high availability, security, and performance for your Azure resources. So let's head over to the Azure Portal and have a look at the Azure Advisor in a real-time way with some of the Azure resources that I've already created. So just as with other resources, like we did with Azure Active Directory earlier, there are lots of different ways to get to different things within the portal. At the top here, I see Advisor already, but I could search for it if I don't see it. I'm going to go ahead and click on it right here to open it up. All right, so there's some good news here and there's some not so good news. It looks like I'm good on performance. I've met all the recommendations for that, but I have some recommendations for high availability and also some for security. Right off the bat, I can see that I have 4 high impact security issues. That's kind of concerning to me. I also have 4 medium impact and 1 low impact. And then I have 3 medium impact recommendations for high availability. So I'm really security minded. Let's go ahead and click on the security tile and let's see some details on exactly what's going on with these. So this gives me a list of the recommendations, and I can scroll down and I can kind of look through these and see what are the different recommendations that Azure Advisor is giving me. I might actually be the right person to address these, or at least some of these, but I might not be. So I can click right here to download a comma-separated values file of these recommendations, or I can download a PDF of these recommendations, and that way I can give these to somebody else who might be more appropriate to take care of them if I need to, and that's pretty convenient. So if I click on one of these recommendations in the list, not only do I get more detail on the recommendation, but if I click on remediation steps, that gives me exactly what I need to do in order to address that recommendation. So that also might be a good way for me to determine whether this is something that I want to do myself or maybe somebody else should be better to do this. If I scroll down a little more, I can also see my affected resources. In this case, it's my entire subscription because it's recommending that I enable multi-factor authentication on my subscription. Now, in this particular case, the remediation steps are some manual steps that I have to go through. But sometimes I can automatically address a recommendation without any manual steps. Let's go back to the list here. And the second list item here is just-in-time network access control should be applied on my virtual machines. If I click on that, it takes me to this pane here, and I can actually select one of these VMs and click on enable JIT on one VMs, and that'll actually take care of that for me. It'll perform that task for me. Alternatively, I could also select both of these VMs, and that would allow me to go ahead and enable that on both of those in one operation. So this gives you a really quick way to address the concerns that Azure Advisor is showing you. So now you have a really good idea of some of the tools that are available to you for managing your Azure resources. We've already talked about Azure Resource Manager, or ARM, and how it helps to create and manage Azure resources. Let's take a deeper look now at ARM templates. ARM templates are JSON files. That means they are human-readable XML files, and they're used by ARM to deploy and configure Azure resources. ARM templates are declarative, and that means you simply use a template to declare what you want done, and ARM takes care of the rest. You don't have to tell ARM how to create or configure a resource. You just tell ARM what resource you want created and how you want it configured, and ARM does it for you. Using ARM templates, you can also specify dependencies. For example, suppose you want ARM to create a web app that uses a VM and a virtual network. And let's say that the VM and the VNet must already exist when you're configuring the web app, or that configuration is going to fail. You can specify that dependency in the ARM template so that ARM will ensure that the VM and the VNet have been successfully created before it creates the web app. So let's switch over to the Azure Portal so we can have a look at an ARM template. So here's a VM in the Azure Portal. Now if I scroll down here in the settings section and I click on Export Template, I can see here the ARM template that is associated with this VM. And I can see right here, if I expand parameters, I can see there are 3 different parameters that are in this template. There's the VM, there's a disk, and there's a network interface. Now if I scroll down here a little more, I can see the resources that this ARM template deploys. Here's the virtual machine that's created. Here is the disk that gets created. And scroll down a little bit more and I can see the network interface here and the properties for it. Now from the portal here, I can click right here and download this template so that I can edit it and use it later. I can also add it to a library, or I can deploy this template and deploy another resource that looks just like this one. Now it's important to realize that you can create your own templates from scratch. You don't have to download a template from an existing resource. You can start completely fresh and create a template that deploys and configures exactly what you need. However, examining the templates in the Azure Portal is a great way to become familiar with how ARM templates look and how they work. Being able to monitor your Azure resources is important, especially so you can understand the health of your resources and whether there's a problem. Azure Monitor makes it easy to monitor your Azure resources because it aggregates all your metrics in a single place, and you can configure alerts that will keep the right people informed of any issues. So let's head on over to the Azure Portal and have a look at Azure Monitor. So here's Azure Monitor in the portal, and as is commonplace with a lot of these Azure services, there is a Getting Started view where you can get an overview of how the feature works and kind of explore through things. There's also tutorials and demos that will give you a lot of information about how to best use Azure Monitor. For this demo, I'm going to click on Metrics right here, and we're going to look at some metrics from some of my Azure resources. Now, as you can see right here, I don't have anything defined in this particular chart. And so what I'm going to do is click on Select Scope right here. And that will allow me to select something that I want to monitor. And in this case, in my AZ-900 resource group, I am going to look at this web app called Learn AZ-900. So that's going to be the scope for my metric right here. And these metrics that are listed here are specific to a web app because the scope that I've selected is a web app. If you select something other than web apps, you'll have other types of metrics that you can look at. So in this particular case, let's just have a look at CPU time. And we can see that we have data automatically populated here immediately. This is a line chart, which kind of makes sense for CPU data. But I can select this right here and look at this differently, like for example as a bar chart. And the interesting thing about Azure Monitor is I can add additional metrics to this and look at those within the same graph. So if I click on Add Metric, I get the same dialog that I had before, And now I can select something, for example, like HTTP server errors. And I can see that there are none of those. So I say, well, that's not useful to me. So what I'd like to do is just get rid of that and add something different. Now, one thing that's interesting to note here is that you can certainly add, for example, data in, and that's going to show me that metric here. But CPU time is in seconds, as you can see here, and data in is in kilobytes. So those two don't really sync with each other. To look at those in the same view just doesn't make a lot of sense. So let's leave data in right there, but over here for CPU time, let's change that to data out so that we're looking at metrics that are in the same measure. So now we have two different metrics, both of which are in kilobytes, and I can see both of those within the same graph. Now we have quite a lot more data out than we do data in, and so the data in metric is very low down in this view. But if I hover over one of these, you can see that it highlights only that metric. And so this gives me the ability to clearly see both of those metrics in one view. And I can also change this maybe to an area chart, which will give me a different view. Let's get rid of this data in. Oh, I should have gotten rid of data out. That was the one that had, let's switch that. There we go. So this is an area chart, which is basically the same as a line chart, but you get the areas filled in. Also, you can do a scatter chart or a grid. A grid is useful if you want to see those values kind of in a table format. Also, note that you can choose the time frame. So this is local time aggregated over the last 24 hours. If I click that, I can change that so that it gives me the range that I'm looking for. And I can even use a custom range. Now, another interesting feature that's available in Monitor is the ability to set alert rules. So if you're looking at something like CPU, for example, I'll switch this back over to CPU real quick. I can actually see that since the last time I looked at this, I had a little bit of a CPU spike here, but let's say that I want to make sure that if my CPU spikes up, the right people get informed about that. So I'm going to go ahead and click on New Alert Rule. My resource is already selected for me here because I was looking at a metric for the Learn AZ-900 app. If I wanted to choose a different resource, I could click Select right here. And now I need to define the condition for my rule. Now by default, I've got whenever the CPU time is, and then I need to apply some logic. That's because I was looking at the CPU metric when I went into the Create Rule dialog. So I just need to define the logic for that. Now the first thing that I see here is a historical view of where CPU has normally been trending in my application. And this is just to give me kind of a ballpark figure or a baseline of where CPU usually is. I did have this little spike here just a little bit earlier, but other than that, you can see my CPU has been trending really low. So let's say that I really would like to be notified if my CPU time goes above, this is 10 seconds right here, so let's say 20 seconds. So I'm going to scroll down here, and first thing I need to do, because this is specific to an app service, is I need to select the instance. This is a VM that's running that web app. And I'm just going to select this one right here. Actually, I only have one instance in my web app, so I only have one VM. And now I'm going to say if the total CPU is greater than, and I said I wanted this to be 20 seconds. So if it's greater than 20 seconds, that's twice the amount that it spiked right here. And then I can have a granularity period here. So I can say if aggregated over a 5-minute period, that threshold is 20 seconds, and it's going to check that every minute. That allows me to make sure that my rule doesn't get triggered if there's just a little blip of activity like there was right here. So now that I've set that up, I'm going to go ahead and click Done. So now I need to specify the action group, and that is telling the rule what to do when this rule gets triggered. And I actually already have an action group. If I select this, I've got this email people action group right here, which I can select. But if I want to have a new action group, just so I can show you kind of some of the options that are available here, I'm going to say this is send text to admin. And this is just going to be called SMS as a short name. My subscription is already correct. This resource group is already existing. This is actually a resource group that was automatically created the first time I created an action group. I'm just going to use that one as fine. And then I need to specify an action group name right here. This is going to be SMS text. And then I can select an action type. And I'm going to select email, SMS, push, and voice. And I can specify now an SMS number. And I can send that to 555-555-1212. Actually, not a valid phone number. So let's just say 214-555-1212. All right. So now I've got my phone number configured, and I can just say OK right here. And that is going to configure that. So I'm going to say OK. And now I have a new action group that's being created real quick here. And once that's created, it is added to that rule. And so now that sends text to an admin when that happens. And I can also, by the way, select the other action group that I had, which is email people. And now it'll do both of these things. It'll send an SMS message, and it'll also email the people that I've configured in that action group. So now that I've done all of this, I can actually go in here to alert details. I can specify some specific information here that gets sent to these people. So I can say CPU was above 20 seconds. Check it out. I can define a severity. So if I want to say this is kind of a Sev1 severity, and now that that's done, I just simply click on Create Alert Rule, and that'll create that alert rule for me. So it's as easy as that to not only monitor your resources using Azure Monitor, but also to create some really complex rules that allow you to make sure that you or someone else gets notified or other actions are taken when your metrics fall outside of the norm. Microsoft operates a web page where you can see the current status of all Azure services, but that's often not the most convenient way to know if a problem in Azure is impacting your particular resources. For that level of detail, you can use Azure Service Health in the Azure Portal. So if I click right here and I query for service, that pulls up Service Health, and I'll click that to open up Service Health. Now the default view shows me any active service issues. I can use these drop downs right here to filter on specific regions and services. So for example, if I want to see only East US VMs that might be impacted by service outage, I can select the East US regions, and then I can drop down here, unselect all of these, and go down and select virtual machines. I can also click right here and I can see any planned maintenance. And notice when I do that, the filters that I set before are still active. I still have 3 selected here and virtual machines. If I want to see resource health on specific resources that I have, I can click here on resource health. And then I can select a resource type. So for example, I can go down here and select IoT Hub because I have one of those. And it will show me the resource health of that particular resource. And notice right now I am healthy because I have a green check mark. I can also check out a history of incidents. So if I click right here on Health History, I can use filters just like I have before to drill down to exactly what I want to look at. But if I scroll down here, I can see that there actually was an event for Azure Monitor. And in the details here, you can see a link that will take you directly to this same screen, so you can provide that to someone else if you want to show them that. It'll show you the impacted regions. It'll give you all of the details on what's going on with that. This gives you issue updates, so it will tell you exactly what's going on in real time as they update that. And once they resolve this particular issue, there will be another tab here that will give you root cause. And you can see here that they expect root cause by 2020-07-25. Now, root cause isn't provided immediately after they have resolved something. It takes them a little time to research things and make sure that they completely understand what happened before they're going to update that with root cause. And by the way, you can also download this issue summary as a PDF, so that's a great way that you can share this with someone else if they need to get updates on it as well. Welcome to Module 4, Describe General Security and Network Security Features. It shouldn't be a surprise to you that security is a big deal for Microsoft and for its customers. In this module, we'll cover some of the features in Azure that can help you address security with your resources. In Lesson 8, we'll talk about the security features in Azure, including Azure Security Center, Key Vault, Azure Sentinel, and Azure Dedicated Host. Then in Lesson 9, you'll learn about network security in Azure. We'll talk about general network security, and we'll look at Azure networking security services like Azure Firewall, Network Security Groups, and Azure DDoS Protection. Lesson 8, Describe Azure Security Features. In this lesson, we'll talk about services in Azure that can help you secure your resources. We'll start off with Azure Security Center and how it can give you security insights and recommendations on best practices, and how it can also help you to fix problems quickly. We'll then talk about how you can secure secrets with Azure Key Vault and how you can secure your data with Azure Sentinel. And that includes on-premises data, data that's in Azure, and even data that's in other clouds. We'll wrap up this lesson with Azure Dedicated Host and how it can help you comply with security requirements that might be in place in your company. Azure Security Center is a single portal for monitoring and managing the security of your Azure resources, but not just Azure resources. The Security Center agent allows for you to do the same for your on-premises resources. There are two tiers of service in Azure Security Center. The free tier offers the service for VMs and app service only. Standard offers the service for virtual machines, app service, but also SQL databases, MySQL, PostgreSQL, blob storage, and many more. Let's head over to the Azure Portal and have a look at Azure Security Center. So we're back in the Azure Portal here. This should look familiar to you by now. And Security Center is one of our Azure services. By the way, if you don't have it listed here in your list of services, you can click More Services and search for it. And if I open the Security Center, I get an overview here of the policy and compliance for my particular subscription. And at the top here, I can also see my secure score, which is right now at 365 out of 565. If I want to dig into more details about my secure score, I can click the link to review my secure score, and as I take actions recommended by Security Center, my overall secure score will improve. And this gives me a great tool for monitoring the overall security of all my Azure resources. And I can also scroll down and look at the resource security hygiene for the different resources that I have. If I'm interested in drilling into this, I can hover over one of these and click on it. And that'll take me to that resource, and it'll show me an overview and it'll also give me some details on things that I need to do to improve my security score for that. Another really important feature of Azure Security Center is regulatory compliance. So if I click on regulatory compliance here on the left, I can see my compliance with different regulatory standards. And if I scroll down, I can see details of each one of those standards as it relates to different areas of compliance. And so I can go in here and expand this, and I can drill in as far as I need to see where I need to take some action on my compliance. And just as you can with a lot of other similar features in Azure, you can download a report of this if you'd like to provide this information to other people who might be better suited to resolve some of these things. Now, if I want an all-in-one view of the security recommendations, I can click Recommendations right here. And that provides a similar view that we were looking at earlier. And here I can also download a comma-separated values report that shows what all of these recommendations are, and then I can provide those to the correct person to take care of those. And notice as I scroll down, I get a nice indicator here that shows me not only what the recommendations are and how many failed resources I have for that recommendation, but I also have the severity level, and I also can see here how much my security score will increase if I address each one of these things. And notice some of these things can be fixed with a quick fix. So for example, if I click here, which says quick fix, this is something that Azure Security Center can actually resolve for me automatically. If I go to remediation steps, I can just click right here to remediate this with a single click. It's pretty common for an application to use sensitive information. For example, you might connect to a database and your application might need access to a username and a password for that database. Now, one option for that kind of thing is to just store the connection string for that database in a configuration file, but doing that could be insecure. Azure Key Vault is a solution for storing secrets, keys, and certificates that an Azure resource might need to use. Once you store something in Key Vault, you can then apply security policies that define which users and applications can access it. Key Vault is encrypted using encryption keys, but Microsoft has no visibility of those encryption keys or the data that you store in Key Vault. Now, there are two pricing tiers for Key Vault, Standard Tier and Premium Tier. In Premium Tier, access keys are stored in hardware security modules, or HSMs. And an HSM is a separate piece of hardware that's specifically designed for securely storing encrypted content. Because the Federal Information Processing Standard, or FIPS 140-2, requires an HSM boundary for encrypted data, the Premium Tier is required for all FIPS 140-2 compliance. Figuring out how to keep your data and resources secure is a really complex task. That's why many companies turn to some tried and proven frameworks to help them focus on what's important. Two of those frameworks are Security Orchestration, Automation, and Response, or SOAR, and Security Information and Event Management, or SIEM. In fact, many companies will use both SOAR and SIEM for their security needs. Implementing these frameworks can be difficult, and a lot of companies will spend a lot of money to hire someone to implement these frameworks for them. Microsoft really wanted to make SOAR and SIEM easier to implement, even for people who aren't security experts. And the result of that work is Azure Sentinel. Azure Sentinel is a service designed to provide threat reporting and analysis for your data and resources. And it's not just for Azure. It can also work with on-premises resources or even resources on other cloud providers. Azure Sentinel sits on top of Azure Log Analytics. As Log Analytics collects information about your resources, Azure Sentinel watches the data for threats and reports on them. To connect Azure Sentinel to your resources, you use connectors. And there are connectors for Azure services, and there are also connectors that enable you to use Sentinel with on-premises resources and with other cloud providers, as I mentioned a minute ago. If Sentinel discovers a threat, it responds to that threat using a playbook. And a playbook is a workflow that performs a series of tasks when a threat is found. Sentinel uses Logic Apps for playbook functionality, and there's an Azure Sentinel trigger in Logic Apps that enables the connection between Logic Apps and Azure Sentinel. When you create a VM in Azure, your VM is running on a physical computer that is not dedicated to you. While your VM itself is isolated, you're still running that VM on a computer that other Azure customers are also using. For many people, that's perfectly fine, but in some situations, that kind of scenario might not meet the requirements. If you need a computer, a physical server, that's dedicated to your Azure subscription, Azure Dedicated Hosts is for you. Azure Dedicated Hosts allow you to achieve dedicated hardware isolation. No one else is using the physical computer that your VMs run on. These dedicated hosts are in the same data centers and have the same networks and other underlying infrastructure, but they're dedicated to your VMs. With Azure Dedicated Hosts, you have control over impact caused by maintenance events in Azure because you can opt in to the exact maintenance window that works best for you. The way this works is you can choose to skip the automatic update to your host and choose your own date and time to apply the update. Now, you'll eventually have to apply the update, but you can choose to do so within a 35-day rolling window, so you have more control over when it gets applied. You can also benefit by using Azure Hybrid Benefit, and this is where you use your own licenses for Windows Server and SQL Server, and you can benefit from using the Standard Edition and also a Data Center Edition license for both VMs and the host computer itself. Azure Dedicated Hosts are created in host groups, and host groups allow you to take advantage of availability zones. You then add your dedicated host to your host group, and then you can run VMs on those hosts. Using Azure Dedicated Hosts can provide both high availability and fault tolerance through the use of availability zones and fault domains. And this will give you the peace of mind when hosting your Azure resources on a dedicated host. Let's continue our discussion of security. In Lesson 9, Describe Azure Network Security, we'll focus on the networking side of security. We'll start off with an explanation of defense in depth and how network security should be structured. We'll then cover how you can secure traffic flowing within your network with network security groups, how you can secure traffic flowing into and out of your network with Azure Firewall, and how you can prevent malicious attacks with Azure DDoS protection. Just for a minute, imagine that you live in this castle in medieval times. Everyone who doesn't live in this castle is fighting to try to get into this castle. So to stop them, the owners of the castle built a tall wall around the castle. And that stopped a lot of people trying to get in, but the persistent intruders just dug tunnels under that wall. So to take care of that, the castle owners put a moat filled with water around the outside of the wall. And by the way, they did not put crocodiles in these moats. I looked it up. Now, even with all that security in place, they also placed archers on the high walls, and they built a sturdy gate at the entrance, and they stationed guards with swords just inside that entrance. This is a great example of what's called defense in depth, and it's why defense in depth is sometimes called the castle approach. This multi-layered approach is the best way to keep your network safe. Azure Firewall can help prevent a bad guy from making it into your network. Network security groups can help control the traffic inside your network. And Azure DDoS protection can help to identify malicious traffic and prevent it from impacting your network. You might remember this image from earlier. It represents a 3-tier application using an Azure virtual network that's divided into 3 subnets. Now, in order to make this kind of configuration secure, you need to control how network traffic can flow. For example, you don't want the middle tier or the data tier to be exposed to the internet, and you don't want the web tier to be able to communicate with the data tier. To control the traffic into and out of an Azure virtual network and between the resources in that network, you can use network security groups, or NSGs. NSGs use inbound and outbound rules to control the flow of network traffic. These rules can use a specific IP address or an IP address range, such as the range of a subnet, and you associate rules with either a subnet or a network interface. You can specify a priority between 100 and 4096 for each rule that's in an NSG, and rules with lower numbers are actually processed first. Once network traffic matches one of your NSG rules, none of the other rules get processed. So that means that a lower priority value is actually a higher priority than a higher priority value. After the rule is matched, the NSG creates a flow record for the connection, and traffic that corresponds to that flow record will be allowed even without an explicit rule. So, for example, if an NSG rule allows incoming traffic to an IP range on port 80, the resulting flow record will also allow outbound traffic on port 80 over that same IP range, even without an explicit outbound rule. But once that traffic stops flowing for a few minutes, that flow record will no longer be effective. Now, there's some cases where you won't know the IP address range of network traffic. Traffic from the internet might be one example of that. But you may also want to apply an NSG to network traffic coming from another Azure service, and you won't always know the IP address range in that scenario either. To solve that problem, NSGs allow you to use service tags to apply rules, and a service tag is a special identifier created by Microsoft that applies to the internet and to Azure services. You know, the internet can be a dangerous place. Check out this scenario. I've got an Azure VM inside of my Azure virtual network, and people from my on-premises office need to connect to this VM. Since people that aren't in my on-premises office can also access this over the network because it's connected to the internet, a bad actor might cause some pretty awful problems for me. Now, to solve this kind of problem, you can use a firewall outside of your virtual network. With a firewall installed and configured to allow traffic only from my on-premises network, that same bad actor is going to be denied access into my network. But people on my on-premises network will be allowed to get to my VM. There are firewalls available from third parties that you can use in Azure, but Microsoft also provides its own firewall that's called, as you might have guessed, Azure Firewall. Azure Firewall is a PaaS offering, and like NSGs, it uses rules to determine if traffic should be allowed. There are 3 types of rules in Azure Firewall. Network Address Translation, or NAT rules, are rules that forward traffic from the firewall to another device on the network. NAT rules are always applied first. Network rules allow traffic on specific IP address ranges and ports, and that's the type of rule I'd likely use to allow people on my on-premises network to access my VM. Application rules allow applications to communicate across my network. So, for example, I could use an application rule to allow Windows Update to communicate across my network. Application rules can also be used to allow domain names. Rules are applied using a priority between 100 and 65,000. And just like priorities on NSG rules, rules that have a lower number are applied first. If network traffic doesn't match any rules, it gets blocked. Azure Firewall is also a stateful firewall, and that means it remembers the state of connections that it allows. For example, if traffic is allowed from my on-premises network, and then a bad guy hacks that connection from another device and attempts to access my resources, Azure Firewall would block that connection because it would notice that the hardware MAC address of the network card using that connection changed. It stores the state of the connection, and if something in that state changes, it will block that traffic. Even traffic that your firewall allows can represent a threat against your application. For example, a distributed denial of service attack, or a DDoS attack, can use what seems like normal traffic to overwhelm an application's resources and make it unavailable. DDoS attacks can also be used to exploit some vulnerabilities that exist within your application. Azure provides a service called DDoS Protection that can help protect you from DDoS attacks. And there are two tiers of DDoS protection, basic and standard. The basic tier protects you from volume-based DDoS attacks by distributing large amounts of volume across a wide array of Azure's infrastructure. This all happens automatically as part of Azure, and you don't have any control over it. You also don't have any reporting capability or visibility into what's happening. As I said, it's all automatic. Standard, on the other hand, is a paid offering, and while basic applies to both IPv4 and IPv6 traffic, standard applies only to IPv6 traffic. The standard tier uses machine learning to profile network traffic and determine the level of the threat. And you can use a single standard plan to protect multiple virtual networks. And that's important because while basic DDoS protection is free, a standard plan will cost you $2,944 per month. As you might imagine, the standard plan is really targeted at enterprise customers who need that level of protection for their apps. Welcome to Module 5, Describe Identity, Governance, Privacy, and Compliance Features. In Lesson 10, we'll talk about authentication and authorization, and we'll talk about Azure Identity services like Azure Active Directory, conditional access, multi-factor authentication, and single sign-on. In Lesson 11, we'll cover governance. You'll learn about role-based access control, Azure policy, resource locks, tags, and Azure blueprints. You'll also find out about the Cloud Adoption Framework for Azure. Then in Lesson 12, we'll discuss privacy and compliance. You'll find out about the Microsoft Privacy Statement, the Online Service Terms and Data Protection Amendment, Trust Center, Azure Compliance, and Azure Sovereign Regions that address specific compliance needs for governments and specific regions. Lesson 10, Describe Core Azure Identity Services. We'll begin this lesson with a discussion of authentication and authorization and how they differ from each other. We'll then talk about Azure Active Directory and how you can use it to control access to Azure resources and to third-party sites as well. You'll learn about how you can use conditional access to enforce policies on the kinds of devices that users use when accessing your resources, and how multi-factor authentication can ensure a more secure experience. We'll also cover single sign-on and how it can make your life easier when it comes to logging into your resources. Here's my shiny new Surface 3 notebook computer. Now when I first sit down at my computer, I have to log in before I can do anything. And I can log in using a few different methods. I might use a password, I might use a biometric device like a fingerprint reader or my camera, and I might also use a certificate. In fact, I might have to use more than one of these methods in combination to log in. Now once I log in, the computer knows who I am. It knows I'm Jim. And this process of determining who you are is called authentication. So now that I've logged in, I decide to create a new document in Microsoft Word. Now at this point, the operating system on the computer has to figure out if I'm even allowed to create a new Word doc on this computer. That process of deciding what I'm allowed to do is called authorization. Now you might have already known what authentication and authorization are, but if you didn't, you'd have a hard time with some of the information we're about to cover. So now that we all know about authentication and authorization, we're all on the same page, let's talk about Azure Active Directory. Azure Active Directory is a cloud-based identity service in Azure, and you can think of identity as a combination of authentication and authorization. Azure Active Directory contains a directory of entities called security principals, and a security principal can be a user principal that refers to a user. It can be a service principal that represents an application in Azure Active Directory, and we'll look at those here in just a minute. And it can also be a managed identity, which is a special kind of service principal for use with Azure resources. Service principals, or entities, can be assigned roles in Azure Active Directory, and those roles determine what that entity can do. That's the authorization component of Azure Active Directory. You can use Azure Active Directory to use identity services with third-party services using Azure Active Directory applications. And there are applications available from Microsoft and from many third parties. For example, you can give someone in your company access to your company's Twitter account by using the Twitter application in Azure Active Directory. Giving access to other accounts using Azure Active Directory is a great solution because when you want to remove that access, you just remove the user's access in Azure Active Directory. If you were instead to give that same user direct access to your Twitter account by giving them your Twitter username and password, you'd have to change your Twitter username and password to remove that access. So let's have a look at Azure Active Directory in the Azure Portal. So I'm here in the Azure Portal, and I'm just going to click right here on Azure Active Directory to open my Active Directory. And if I click here on Users, I can see all of the users that are members of my Azure Active Directory. And if I click on one of these users, I can see when that user is signed in, I can see information on that user's identity, and if I scroll down, I have other information as well. In this case, I don't have information filled in for contact info, but if I did, I'd have all of that information here as well. Now, this user, as it so happens, is my user account as an admin of this subscription, and it's a Microsoft account. But you can also have guest users in Azure Active Directory. So if I go back here to the All Users screen, I can create a new user here, which actually would be either an Azure Active Directory user or a Microsoft account. But if I have someone who maybe exists in a different company and I want them to have some level of access to my Azure resources, I can use the guest user option, and then I can either create a user and give their user ID, or I can invite a user from a different organization as a guest user, and then they can actually collaborate with me with my Azure resources. Now, one important concept of this is the concept of roles. And if I go into roles and administrators, I can see the roles that are available within my Azure Active Directory. So I see that I have application administrator, I see a description of that role, And so when I create users, I can assign them to a specific role, and that controls what level of access they have to my Azure Active Directory. So for example, if I go back into users and I look at my user account, and then I click on Assigned Roles, I can see which roles have been applied to this particular user. You've seen that you can use Azure Active Directory to give users access to apps and resources, but you might want to take security a step further. Suppose, for example, you've given a user access to your Microsoft 365 account through Azure Active Directory, but you want to make sure that user can't access your account using a mobile device. Or let's say you want to allow that user to access the account only from certain networks. Azure Conditional Access will give you that level of control. Conditional Access uses policies that you can apply to users, and those policies are applied using assignments and access controls. Assignments define who a policy applies to and also the conditions that must be met, such as a certain platform like iOS, Android, or Windows. Assignments can also be used to require a certain IP address range or something like that. Access controls determine how a policy is enforced. The most restrictive access control is block access, but you can also use access controls to do things such as require that a user's device meet certain conditions or that they're using an approved application to access your resources. Conditional access is available only in the Azure Active Directory Premium tier. By the way, you can also use conditional access to require that a user authenticates using multi-factor authentication. Now remember when we talked about authentication that I pointed out that you can authenticate using different methods, and these methods are referred to as authentication factors. And multi-factor authentication requires that you use more than one factor. One authentication factor is something you know, such as a username or a password. Another factor is something you have, such as a phone or a tablet, or it might also be a device that can display a time-sensitive access code you have to enter. The third factor is something that you are, and this refers to your fingerprint or some other biometric component, such as your facial structure, or even the pattern of blood vessels in your retina. Azure Active Directory offers multi-factor authentication, and Azure multi-factor authentication is two-factor authentication. That means it requires that you use the first two authentication factors in order to log in. Azure multi-factor authentication is only available in the Azure Active Directory Premium plans, and you enable it in the All Users blade of your Azure Active Directory in the Azure Portal. You enable multi-factor authentication on a per-user basis, and you can also configure it for guest users in Azure Active Directory by using conditional access. Another great identity feature in Azure is called single sign-on. Suppose you need to use data from multiple servers to prepare a report for your manager. Each time you access a different server, you have to enter your username and your password all over again, and that can get pretty frustrating. With single sign-on, you log in with your credentials once, and your credentials are then sent to an identity provider, and that identity provider uses your credentials to issue you a token, and a token is just an encrypted entity that you can use to authenticate. When you access other servers, instead of having to enter your username and password again, the server simply uses the token that you've already received to log you in. Tokens have information embedded in them that makes all this possible, and those pieces of information are referred to as claims. There's a claim that defines who you are, a claim that tells the server when the token was issued and when it expires. And there's also a claim that lets the server know the token is valid for that specific server. Lesson 11. Describe Azure governance features. In this lesson, you'll learn about role-based access control and how you can use it to give others a specific level of access to your resources. You'll find out how you can use locks and how they can prevent others from changing or deleting resources. We'll talk about tags for resources, and you'll find out about Azure policy to control the way that others who have access to your Azure resources can interact with them. We'll talk about how you can create easily reproducible environments using Azure blueprints. And we'll wrap up the lesson with a discussion of the Cloud Adoption Framework for Azure. So you've learned about some cool features for authenticating and authorizing users, but let's take the concept of authorization a little deeper. Suppose you want to allow users in a certain department of your company to access some of the virtual machines in your Azure account, and some of those users should also be able to not only remote into the VMs, but also change some settings on the VMs. Others should be allowed access, but not be allowed to change any settings. Now that sounds like a pretty complicated thing to do based on what you've learned so far, but it's actually easy using a feature called role-based access control. Role-based access control, or RBAC, authorizes users to perform certain things using a role that you assign the user to. In Azure, role-based access control is based on 4 elements. The first element is a security principle, which is an element that represents an identity. A security principle can be a user, but it can also be a group or an application. And when a security principle represents an application, it's actually called a service principle. A security principle can also be a special entity called a managed identity. And managed identities allow you to authorize an Azure service. The next element is a role. And the role, or a role definition, defines how the security principle can interact with an Azure resource. For example, the role might define that the security principle can read the properties of a resource, but it can't change any of those properties. The third element is scope, and this defines the level at which the role is applied. So for example, if the scope is a resource group, the role applies to all resources in the resource group. And the fourth and final element is role assignments. Roles are assigned to a security principle at a particular scope, and that's what ultimately defines the level of access for the security principle. Now, RBAC includes many common built-in roles, and 3 of these apply to all Azure resources. They're the owner role, which gives the security principle full access to resources, the contributor role, which allows for resources to be created and managed, but the role can't be delegated to another security principle. And then the reader role gives access to see Azure resources, but it does not allow for resources to be created, deleted, or managed. So to make this clearer, let's have a look at RBAC in the Azure Portal. This is my virtual machine in the Azure Portal. And if I wanted to give someone the ability to access this virtual machine, I can click right here on Access Control. This is where you configure RBAC in the Azure Portal. So the first thing I want to do is click on Add, and that allows me to add a role assignment for a user. I'm going to select one of the built-in roles, and we talked about the top 3 earlier, the owner, contributor, and reader. I'm actually going to give someone contributor access to this particular VM. So I'll select contributor. Now I need to determine, am I going to assign this access to a user, a group, or a service principal? And notice if I drop this down, I can see also some managed identities. We've talked a little bit about managed identities before, and notice that those managed identities are all Azure services. So I could give, for example, app service access to this VM by just selecting this. In this case, I'm going to use a user, and I'm going to have a user who is actually a member of my Azure Active Directory, and that's this person right here, Christine Conrad. So I've selected her. She now appears down here under selected members, and now I'm going to save. So once I've added her, if I go into role assignments, I can see that a contributor on this VM is Christine Conrad. I can see her role right here. And notice the scope is this resource. Notice also that Gem Test right here is a reader on this VM, but the scope of that is at the subscription level. So that means that this user, Gem Test, has reader role assignment to everything within this subscription. If I wanted to remove Gem from that, I would need to go to the subscription and remove him. Locks prevent changes or deleting of Azure resources, and unlike RBAC, locks apply to all users no matter what level of access they have to that resource. So let's look at a quick example of using locks. So here's one of my VMs in the Azure Portal. Let's go ahead and add a lock to this so it can't be deleted. So I'm going to go down in the menu here, and I'm underneath the settings area. I'm going to choose locks. There are no locks currently assigned to this, so I'm going to go ahead and click add. I'm going to give this lock a name, which is no delete, because I want to create a lock that keeps people from deleting this. And then I choose the lock type. Now notice there are a couple of different lock types. There's read only, which means that you can look at this resource, but you can't change anything. You can't change the configuration, and by the way, you also can't delete it. Or there's a delete lock, which means you can change the configuration of this all you want to, but if you try to delete it, it's not going to allow you to do that. So let's make this a delete lock. I can add some notes if I want to. Don't really need to do that, so I'm going to say OK. And now there is a lock on this VM. So let's go back to the home screen, and I'm going to go back into that VM. And what I want to do now is I want to delete this virtual machine. So I'll click on delete right here, and it warns me this is actually going to delete it. I'll say yes, and notice it didn't work. And the reason for that is because there's a lock on this VM, and that prevents me from deleting it. So if I wanted to remove that lock so I can delete it, I can go down here to locks again, and I'll scroll over here a little bit. This is the no delete lock that I created. So if I click on delete right here, I can delete that lock, and now I would be able to delete that VM. One of the features in Azure that makes it easier to manage and organize resources is tags. A tag is a name-value pair that is applied to Azure resources. The name and value can both be anything you decide. For example, if you have a lot of Azure VMs for the sales department in your company, and you have other VMs for the IT department, you could tag each with a name of department and a value of either sales or IT. And you can then view all resources associated with a specific tag in the Azure Portal. Another big advantage to tags is that they help you with billing. Your Azure invoice will display the tags you've added to your resources. So in the example I just used, you'd be able to easily see how much your sales department VMs cost and how much your IT department VMs cost. In addition to security concerns, you're likely going to encounter governance concerns with cloud applications. For example, your company might have a policy that specifies that no virtual machine should be created within a particular region because that region doesn't offer some required features that you have. Azure Policy is a tool that can help you to enforce policies like this. Azure Policy uses policies to define rules that apply to Azure resource creation and management. So let's have a look at Azure Policy in the Azure Portal. So here's Azure Policy in the portal. Now the first thing you might want to do is check out the Getting Started page right here. This is where you can access information on viewing definitions and assigning policies and checking out compliance of your policies and even creating your own custom policies. You can also see some recommended policy assignments here that you can apply just by clicking on them. Now if I want to see all of the policy definitions that are in effect for me, I can click on Definitions right here, and I see that there are many different built-in policies that are currently in effect for me. If I want to create my own policy, I can click right here on Policy Definition, and now I can define my own policy. And one of the interesting aspects of policies is this property right here called Effect. In this sample rule, you can see that the effect is audit, and that means that if this policy is not complied with, a warning will be logged so that I'll be aware of it. However, there are actually 5 other effects that you can specify in a policy. The append effect adds additional properties to a resource, and this can be used to do things like automatically add a tag with a specific value to resources when they get created. The audit if not exists effect allows me to specify a resource type that must exist along with the resource that's being created, and if that resource type does not exist, a warning gets logged. The deny effect denies the create or update operation, and the deploy if not exists is similar to the audit if not exists effect, but instead of just logging a warning, it will automatically deploy the required resource type. And finally, the disabled effect means that the policy is not in effect. So once I've created a policy, I can assign that policy by going right here to Assignments, and then I can click here on Assign Policy and assign that policy to my subscription or to another scope. Now if I click here on scope, I can see that subscription is my option for scope. I can also assign this to a particular resource group. So I'm going to go ahead and click on select right here to apply this to my subscription. And the next thing you can do is assign exclusions. Those are specific resources that are exempt. Then you point to your policy definition that you've created right here. You give it a name of your choice, you give it a subscription of your choice, and then you choose whether or not it's either enabled or disabled. After you do that, you can click Review and Create, and that assigns your policy. When you decide to create a cloud application, you normally wouldn't just open the Azure portal and start creating resources. Instead, you'd want to plan your application and make sure the architecture complies with your standards. You need to plan out your virtual network and how it's configured and decide on all the other resource configurations to support your app. There's actually a lot of risk in not planning carefully, and for that reason, most companies will have people with a lot of expertise in doing that kind of work. If you need to deploy your application to another Azure region, you might have to go through that whole process again, and that can end up getting pretty expensive. To help with that problem, Microsoft developed Azure Blueprints. Azure Blueprints allows you to easily reuse configurations, policies, and governance, and that makes deploying to the cloud a lot easier. You configure everything the way it needs to be, apply your policies and governance, things like RBAC, and then you can save that configuration and easily deploy it at any time. Any items that you add to a blueprint are called artifacts. And an artifact can be a resource group, an ARM template, a policy assignment, or a role assignment. Blueprints can be saved to either a subscription or a management group. If you save it in a management group, it can then be used with any subscription that's part of that management group. After you create a blueprint, you publish it, which saves the blueprint. And when you publish it, you provide a version number so you can identify which version it is. And also, you have the option of providing change notes. After you publish it, you can assign it to a subscription. And when you assign the blueprint, it automatically creates all the resources that are defined in the blueprint. Now, you might be wondering what the difference is between a blueprint and an ARM template. Well, you can include an ARM template inside a blueprint as an artifact. And in fact, most blueprints will use ARM templates for deploying Azure resources. However, unlike ARM templates, which are just files that define a deployment, a blueprint is an Azure resource itself, and that means that Azure can maintain a connection between the blueprint and the resources that use it. This makes it easy for you to iterate on your blueprints and improve them, and because you add a version number when you publish a blueprint, you can store them in a source control system to make them easy to track. You've seen that moving to the cloud is not as simple as just opening the Azure portal and clicking some buttons. Moving to the cloud involves a lot of careful planning and education, and you need to learn how to move to the cloud successfully if you're not familiar with it. You have to learn about best practices, how cloud apps should be architected, how to migrate resources, setting up governance and policies, and more. There's a lot to learn. To help you learn what you need to know, Microsoft created the Cloud Adoption Framework for Azure to bring together best practices from Microsoft employees, Microsoft partners, and lessons learned from other Microsoft customers. All this information is available in the Cloud Adoption Framework for Azure website, and you can access that website by browsing to aka.ms/Cloud Adoption Framework. Lesson 12, describe privacy and compliance resources. In this lesson, you'll learn about the Microsoft core tenets of security, privacy, and compliance. We'll cover the Microsoft Privacy Statement and Microsoft's approach to privacy. You'll find out about the Online Service Terms and Data Protection Amendment, resources that provide transparency into Microsoft services and how they use your data. We'll talk about Trust Center and Microsoft's stance on trust. And we'll cover the Azure compliance documentation that covers just about every data compliance regulation across the globe. We'll also talk about Microsoft's sovereign regions for adherence with specific regulatory requirements in Azure. Let's talk about security, privacy, and compliance. First, security. We all know how important security is. When it comes to the cloud, you need to know that your cloud provider is operating their cloud environment in a secure way. And you also need to know that data you store in the cloud is secure. Microsoft takes security extremely seriously, and they have a global team of security experts who use technology like artificial intelligence and machine learning to keep an eye on what's happening in Azure and keep your resources and your data safe. Microsoft also offers portals like the Trust Center to keep you informed on security, and we'll cover Trust Center later in this module. Microsoft also provides you with the flexibility to configure the security of your resources to meet your needs. Services like Web Application Firewall and VPN Gateway are examples of offerings in Azure that allow you to enhance security, but there are also features of Azure that span across resources, things like role-based access control, Azure Monitor, and Azure Advisor, and of course you can't forget about Azure Security Center. And all of these just touch the surface. There are a ton of other features and services in Azure that are designed for security. Azure Load Balancer, Azure Application Gateway, network security groups, force tunneling, data encryption, shared access signatures, penetration testing. The list just goes on and on. But even with all of that, remember that when you're dealing with the cloud, you're dealing with a shared responsibility model. And that means you will need to make sure you're doing your part to keep things secure. But don't worry about that. Microsoft provides plenty of guidance there as well. And with tools like Azure Security Center and Azure Advisor, you have information at your fingertips that can help ensure your resources and data are safe. Another concept that Microsoft focuses intently on is privacy. Now, we've talked about this a little already, but when you're storing sensitive data in the cloud, you want to make sure that data remains private. Microsoft assures that data you store in Azure is private. They don't mine your data in any way. Microsoft gives you full control over where your data is stored, and they provide the tools you need to control who has access to your data. Microsoft assures you of this with the Microsoft Privacy Statement, but Microsoft also complies with privacy standards such as ISO 27018, the EU Model Clauses, EU-US Privacy Shield, FERPA, HIPAA, and many others. Microsoft also realizes that you have requirements you must meet related to standards and requirements, and they offer many ways for you to monitor compliance in Azure. The list of regulatory standards Azure complies with is comprehensive, and in cases where you share in the responsibility of those requirements, Microsoft gives you tools not only to determine what your responsibility is, but also to help you meet them. Tools such as Microsoft Trust Center, Service Trust Center, Azure Policy, Azure Blueprints, and more, those can help you assure compliance. If you want to read more about security, privacy, and compliance in Azure, check out the Security, Privacy, and Compliance in Microsoft Azure white paper by browsing to https://bit.ly/AZ-900-SPC. Customer trust is one of Microsoft's core guiding principles, and keeping you informed about the information they collect and how they use it is also important. And that's why Microsoft publishes a privacy statement that provides you with the personal data that Microsoft collects and how they use it. The privacy statement also outlines reasons why Microsoft might share personal data, such as when you conduct a transaction with Microsoft, or if they're required to share data by law. You're also notified about how to access the data that Microsoft has collected and how you can control it, including the ability to opt out of internet-based targeted advertising. Microsoft also includes information about how they use cookies on their websites, and they detail the data that's shared with third parties when you use your Microsoft account for authentication. And finally, the privacy statement details how Microsoft secures data, where they process that data, and the policies that define how long the data gets retained. You can access the Microsoft privacy statement by browsing to aka.ms/privacy statement. Microsoft wants to make Azure's terms of service and their stance on data protection crystal clear. So they operate a web portal where you can read all about product terms. Now, as of this recording, Azure Terms of Service are available in a document called Online Service Terms, or OST. The data protection terms are provided in a document called the Data Protection Amendment, or DPA. You can find both of these by browsing to http://aka.ms/OST. In the future, Microsoft will offer all of this information in the new product term site located at https://www.microsoft.com /licensing terms. From the product term site, you can search for a Microsoft program and read all the program terms. You can also view terms for all online services and more. The Microsoft privacy statement is all about transparency and how Microsoft deals with your data. But Microsoft also wants to be fully transparent in how they deal with security, privacy, and compliance. All information related to these core tenets is shared in the Trust Center, which is a web portal that details Microsoft's commitment to trust. Here's the Trust Center. If I scroll down, you can see links on how Microsoft deals with security, privacy, and compliance. And you can also see, if I scroll down a little further here, you can see links to blogs that Microsoft maintains and some offerings that help you to maintain compliance. Information on law enforcement data, requests that Microsoft has received, and a report on U.S. national security orders. You scroll down a little more and you can see some events that Microsoft holds for its customers that are related to security and compliance. This kind of transparency can really help you to have confidence in the security of the data that you store in Azure, and it's a really clear indicator of how serious Microsoft is about earning and keeping the trust of its customers. We've already talked a bit about compliance, and there's no doubt that compliance is both extremely important and extremely complex. Chances are your organization has to comply with at least some regulatory standards, and that means you'll need assurance and documentation that Azure complies with those standards as well. Microsoft has comprehensive documentation on compliance to help you out in this area. They provide details on each regulation or standard, and they detail Microsoft's approach to each. And they also provide FAQs and information on using your compliance score to assess your resources. They also provide many additional resources to help keep you informed. Microsoft also provides a comprehensive list of compliance resources that cover everything from audit reports to compliance guides for different countries, so you can be confident in your compliance no matter where you're doing business. All of this compliance documentation is available by browsing to http://bit.ly AZ-900-compliance docs. You've learned how you can use Azure Policy to enforce compliance, but sometimes compliance can't be met by just applying policies. For example, some areas in the U.S. government require that all data stays in the United States and that only citizens of the U.S. have access to any system that stores that data. You can't meet that kind of requirement with policies, so Microsoft has created a completely isolated cloud called Azure Government. Azure Government enforces the requirements of the U.S. government, and it's only accessible by Microsoft employees who are U.S. citizens and who are screened. Azure Government uses completely isolated data centers and express route locations, and they use their own dedicated fiber. Azure Government isn't only for the federal government. City and municipal governments can use it as well, but Microsoft will vet everyone who attempts to sign up for Azure Government to ensure they're a representative of the government. Azure Government has all the same features as the public cloud, but there are some small differences. For example, you access Azure Government using the URL portal.azure.us instead of portal.azure.com. The United States Department of Defense has additional compliance requirements that are called DoD Impact Level 5 Provisional Authorization. and it's meant to allow for the storage of controlled, unclassified information. There is a subset of data centers in Azure Government that are compliant with DoD Impact Level 5 provisional authorization. There are also important regulations in the EU that must be met for any country operating within the EU, and to address that, Microsoft created a distinct cloud in the EU called Azure Germany. Azure Germany is available for customers in the EU, the European Free Trade Association, and in the UK. Azure Germany data centers are all located in Germany, and they're operated under strict security measures by a local company named T-Systems International. This is a subsidiary of Deutsche Telekom. T-Systems International operates as the data trustee, and they have full control over all of the data in Azure Germany. Microsoft is only involved in managing the systems. They have no access to the data that's in Azure Germany. Now, there's a third sovereign cloud located in China called, Azure China. Azure China is operated by Shanghai Blue Cloud Technology Company Limited, but it's often referred to as simply Blue Cloud. And Blue Cloud is owned by Beijing 21 Vianet Broadband Data Center Company Limited, and they're usually referred to as 21 Vianet. Azure China isn't currently full-featured, but Microsoft is working hard to add new features all the time. For the most updated list, check out bit.ly/AZ-900-Azure China. Welcome to Module 6. Describe Azure pricing, SLAs, and service lifecycles. In Lesson 13, we'll talk about the factors that can affect your costs, and you'll learn how you can forecast and manage your costs. You'll even learn how you can forecast costs before you create your first Azure service. In Lesson 14, we'll talk all about Azure SLAs, and you'll learn about preview services and features and how the Azure lifecycle works. Lesson 13, describe methods for planning and management of costs. This lesson is where you'll learn about some of the factors that can affect your costs in Azure and how you can plan accordingly to ensure you save money wherever possible. We'll talk about the pricing calculator and the total cost of ownership calculator, two tools that can help you with forecasting your costs before you move to Azure. We'll wrap up with a discussion of Azure Cost Management, a tool for helping you keep a close eye on your costs in Azure. As you're planning your Azure deployments, you should always keep the factors that can affect your costs in mind. There are meters assigned to every resource, and this is how Microsoft charges you for those resources. For example, you aren't explicitly charged for an Azure Virtual Network. Instead, you're charged for traffic that flows into and out of the network, and meters are used to track that data. To keep costs as low as possible, you should plan how you purchase your resources. For example, if you agree to pay in advance using an enterprise agreement, you can save a lot of money. Cloud solution partners might also provide you with complete solutions that are more cost-effective than purchasing all of the services yourself. You should also keep in mind that resources in some regions cost more than those same resources in a different region. For example, a VM deployed to the central US region will cost more than the same VM deployed to the East US region. Even so, deploying to the cheapest region isn't always the best choice, because if you have to pay for network traffic between regions, that could actually increase your costs. You can also significantly reduce your costs by taking advantage of reserved instances and reserved capacity. Reserved instances are Azure VMs that you commit to using for either 1 year or 3 years. Reserved capacity refers to a commitment to workloads on Azure SQL Database, Azure Cosmos DB, Azure Synapse Analytics, or Azure Cache for Redis. Reserved instances can save you up to 72% on VMs, and reserved capacity can save anywhere from 33 to 80% based on your usage. Another great way to save money is by using Azure's Hybrid Use Benefit. Hybrid Use Benefit allows you to use your existing Windows Server or SQL Server licenses for cloud-based resources. Using Hybrid Benefit pricing, you can save up to 40% on VMs and up to 55% on Azure SQL Database. And combine that with reserved instances, and you can save even more. If you want to use a VM for a workload that isn't time sensitive and that can stand to be interrupted, you can save by using spot pricing. Spot VMs are allocated in Azure's unused VM capacity pool, but if a spot VM is needed to satisfy capacity requirements from Azure customers, Microsoft will either deallocate the VM or delete the VM based on how you configure it. If a VM is configured to be deallocated when Azure needs it, you might be able to redeploy that VM later, but it's not guaranteed. Therefore, you need to carefully check your requirements to ensure that this is a good option for you. One other factor that affects costs is the zone that you deploy to. Microsoft separates Azure regions into 4 separate groups for billing purposes. And these groups are called billing zones or simply zones. Microsoft's network costs in these zones differs, so your cost will differ too. The cheapest outbound network costs are in Zone 1. DE Zone 1 is the second cheapest, followed by Zone 2 and then Zone 3. All the zones are listed here, along with all the regions that are in each zone. So as we've seen, there are many factors that can impact your Azure costs, and it can be pretty hard to try and predict your costs in advance. And that's why Microsoft created the pricing calculator. The pricing calculator can provide you with an estimate of your Azure expenses, and it bases that estimate on the type of product you choose, but it also factors in where that product is deployed, because as you've seen, costs differ depending on region and zone. And it also accounts for other factors that can impact your costs. You can access the pricing calculator by browsing to aka.ms/Azure pricing. So let's head over there and let's have a look at the pricing calculator. So this is the pricing calculator in my browser. And by default on this screen, we have a list of products that I can add to an estimate. But I can also click on the Example Scenarios tab, and I can get a list of different scenarios that might reflect what I want to do in Azure and get an estimate on those, which includes numerous different products. In this example, I'm going to just choose Products, and for this demo, I'm just going to use virtual machines to kind of show you how the calculator works. So to add virtual machines to my estimate, I just click on it. And you'll notice that will tell me virtual machines have been added. Now to see my estimate, I need to scroll down to right here. Now this is the estimate that I have for virtual machines, and this is the default setting for that estimate. So I can see here that my estimate total is $152.62. But let's say that I don't want to deploy this to West US. I'm actually going to deploy this to the East US. So I'll select East US as my region, and notice that automatically my price has dropped now to $137.29. I can also choose a different operating system, so I'll choose Linux, and notice here my price has dropped again, and that's because now I don't have to pay for Windows licensing. And so every time that you make changes in the calculator, it's going to update your estimate based on that. So I can go down and I can choose what type of instance I want. And notice there are a very large number of instance types. If I have the need only for 1 CPU and 28 gigabytes of RAM and 56 gigabytes of temporary storage, I can select that, and that's going to also update my estimate total. So now I have a larger estimate because I am actually using a more powerful machine. I can also choose my billing option. So if I see pay-as-you-go is going to give me 270.83, but if I choose one of these agreements and I commit to a longer term pricing, I can get quite substantial savings. Also, I have the ability to choose manage disks. I can actually change my tier here. I can change my disk size. I can change the number of disks, etc. And I can change my storage transactions as well. I can choose whether or not I want to include a support plan and whether I want to choose any other programs and offers. And then what I can do is choose purchase options to see how I can purchase that particular estimate. Now I can also save this estimate and I can export this estimate to Excel, or I can share it with someone. If I save it, if I scroll back up here to the top, you'll see I have the ability to click Saved Estimate. So if I save my estimate, I can go back to it at a later time. That allows me to maybe tweak it a little more later, or if I want to save that and export it later on, I can do that as well. The pricing calculator is a good way to estimate your Azure expenses. But if you want to estimate how much money Azure could save you versus your on-premises deployments, the total cost of ownership calculator, or the TCO calculator, is the right tool for the job. The TCO calculator provides an estimate of cost savings that you could realize by moving on-premises applications to the cloud. And data in the TCO calculator is based on expense information for on-premises resources that Microsoft has accumulated over many years of experience. TCO calculator includes detailed charts on expense savings over a long period of time by moving to Azure. And you can access the TCO calculator by browsing to aka.ms/Azure TCO. So let's go have a look at the TCO calculator. So here is the TCO calculator in the browser, and the very first thing you have to do is you have to define your workloads. Now this means you have to tell the TCO calculator what your on-premises application needs. So if I click on Add Server Workload here, I can adjust this based on what my particular application uses. So let's say that it uses a Windows physical server using Windows. I'm going to say one server. Let's say that I have 2 procs in my servers, and each of those are 2 core procs. And I have, let's say, maybe 16 gigabytes of RAM in each one of those, and all of that looks good. Now if I click here to add Windows Server 2008 R2, that's also going to adjust my particular details on my workload. Okay, so now I've got this workload. I've called this workload 1, so that's fine. I'm going to go down here now and add a database. And I'm going to accept all the defaults for this. I'm going to say it's a Microsoft SQL Server database, and that's fine. Storage, I can add networking. So those are all of the different workloads that I can add. Now, let's say that I have multiple servers. So let's say that this particular server is actually my application server. Let's say that I might also have another server that's like a business logic server or something like that. I can click Add Server Workload here and add an additional server. Okay, so this is our application database. Now I'm going to add some storage here, and this is where I add my disk drives. So I'm going to say a 1 terabyte disk drive. That's totally fine. This is our hard disk storage. And my network bandwidth, 1 gigabyte. That's totally fine. So I'm going to go ahead and click Next. And now I can adjust my assumptions. Now these are the assumptions that, as I said earlier, are based off of years of data that Microsoft has accumulated. And so what it's going to do is assume some things based off of what I have given it. And I can scroll down here and I can see all of the different assumptions that Microsoft has made, and that includes electricity costs, that includes storage costs, IT labor costs, and any other assumptions. As long as I'm satisfied with what's here, I can go ahead and click Next, or I can adjust them. I'm just going to go ahead and click Next. That's fine. And now I can view a report that will show me how much I can save. So I can see here over 5 years with Microsoft Azure, my estimated cost savings could be as much as $186,423. So that seems like something that I might definitely want to consider moving to the cloud. Also down here, notice I have this graph which shows me my costs over that 5-year period on premises versus in the cloud. I also have some other pie charts down here that actually show me some of my expense data broken out into different categories, and then I can also see additional breakdown as well. So this is a very detailed analysis of how much I would pay for this application on premises versus how much I would pay on Azure. So when I get down to the bottom here, I have the ability to download this report, share this report, or save it with someone. But let's say that I look at that and I say, I'm sold. I definitely want to get this up and running. And in fact, I'm saving so much money, I want to do this immediately. I can create a free Azure account right here and start experimenting with that. Or I can click this button and have Microsoft contact me for some discussions about how I might want to purchase an enterprise agreement or other ways that I can save additional costs as I look at implementing this solution within Azure. Azure Cost Management is another tool that allows you to keep an eye on your costs and manage your expenses in Azure. Azure Cost Management makes it possible to analyze your costs at a granular level, and you can create budgets so that you can control your costs, and you can even create alerts that will notify specific people when certain thresholds are exceeded in your costs. Azure Cost Management is available in the Azure Portal by searching for Cost Management plus Billing. So as you can see here, Azure Cost Management provides a breakdown of your expenses by resource type, region, and resource group. And I can also see a graph of my costs over time. I can budget my expenses in Azure Cost Management, and if I exceed my budget, I can clearly see that in my cost analysis graph. So this is a great way to keep an eye on my expenses in Azure over time and to make sure that I'm making the best use of my cloud resources. Lesson 14. Describe Azure Service Level Agreements, SLAs, and service life cycles. In this lesson, you'll learn about what an SLA is in Azure. We'll also cover the life cycle of Azure services and how a service makes it to production quality. Service level agreements, or SLAs, establish specific targets for availability, and they also define what a cloud provider will do when those targets aren't met. SLAs are represented as a percentage of availability over a specific time period, and they're usually above 99%. I mean, if a cloud provider promised that your service would be available 80% of the time, you'd likely go somewhere else for your cloud application needs. No one is going to offer a 100% SLA. It's just simply not possible. The highest SLA is 99.999%, which is commonly referred to as 5 nines. This is obviously what all cloud providers aim for, but a more typical SLA is 99.9% or 99.95%. A service is only outside of an SLA if a problem is caused by something that's within the control of the cloud provider. If a problem is caused by your application or maybe another component that the cloud provider doesn't control, there is no SLA on that. If a service's availability does fall outside of the SLA, the cloud provider will often provide some level of refund, but in Azure, you must submit a claim to Microsoft within 2 months of the end of the billing cycle. As Azure product teams create new features and services, they'll often offer pre-release versions to customers. Microsoft calls these pre-releases previews, and there are two different types of previews: private previews and public previews. And then once a service or a feature leaves preview, it's considered generally available or GA. Private previews are normally offered only to a very small number of customers, and they're often offered by invitation. Public previews, on the other hand, are available to most Azure customers. Preview features are not designed for production use. They can change often, and some of those changes might actually break your resources. Also, for that reason, previews offer no SLA, but they're often offered at a reduced price. Preview features in the Azure Portal will usually display preview badging. For example, in this image, you can see Azure App Service Editor, and it's clearly labeled as a preview feature. You'll likely see this kind of badging in many other Azure services as well. Well, that's it. You've completed your journey through Azure Fundamentals. You now have some great knowledge about Azure under your belt so that you can be better prepared to take the AZ-900 exam. You're also prepared to be a valuable resource in your company for evaluating and recommending your company's approach to the cloud. In this course, you learned all about cloud concepts. You learned what benefits the cloud provides, and you learned about the different service types available, such as IaaS, PaaS, and SaaS. You also gained a deeper understanding of the differences between the public cloud, the private cloud, and hybrid cloud scenarios. You learned all about some of the core services in Azure, and you learned about some of the under-the-hood concepts, such as Azure Regions, Availability Zones, and Azure Resource Manager. You learned all about core services in Azure. You learned about compute products, networking, storage, and database solutions. And you learned about the Azure Marketplace for jump-starting your cloud experience. You also learned about cool technologies like the Internet of Things, artificial intelligence, and you learned about machine learning and serverless computing in Azure. You also learned how to use the Azure Portal, PowerShell, and the Azure CLI to manage all these services, and you learned about Cloud Shell and using the Azure app on your mobile device. You found out how you can use Azure Monitor to keep track of all your Azure services, and you learned how to configure alerts so the right people are notified of problems when necessary. You learned how you can monitor the health of Azure itself with Azure Service Health, so you'll know if you're being impacted by a problem in Azure. You learned about security, privacy, and trust, and you learned about compliance with regulations. You learned about Azure security products such as Azure Firewall and Azure DDoS Protection. You learned about how to use network security groups and how to best choose the right security option for your needs. You learned about identity solutions such as Azure Active Directory and multi-factor authentication. You also learned how you can control how users access your resources using conditional access and role-based access control. You now know how you can manage the creation and management of Azure resources using Azure Policy. And you learned about preventing unwanted changes using locks, and even how you can keep someone from unintentionally deleting an Azure resource. You also learned about using tags to organize your resources, and how you can use Azure Blueprints to create reusable environments configured for your specific needs. You discovered Microsoft's approach to privacy and trust, and you learned about tools like Trust Center online service terms, the data protection amendment, and Azure compliance documentation. You also learned about Microsoft's sovereign regions and Microsoft's approach to the unique security and compliance needs of governments in other countries. Finally, you learned all about Azure pricing, SLAs, and service lifecycles. You learned all about the tools you can use to plan and manage costs, tools like Pricing Calculator and the Total Cost of Ownership Calculator. You learned about Azure Cost Management so that you can easily track your costs and make wise financial decisions about your cloud usage. You learned about the Azure SLA, and we wrapped up with a discussion of the service lifecycle and how you can keep up with feature and service updates, as well as how you can access new features early in the development process. With all this knowledge, you're now much better prepared to take the AZ-900 Microsoft Azure Fundamentals exam. I hope what you learn in this course gives you confidence in your knowledge of Azure, and I hope you enjoyed taking this course as much as I enjoyed teaching you. Thank you, and good luck on your exam.